Given the millions of billions of Earth-like planets, life elsewhere in the universe, without a doubt, does exist. In the vastness of the universe, we are not alone. Albert Einstein. 4.5 billion years ago, in the vastness of the universe, the Earth, our home, was formed. From the birth of the universe, it took 14 billion years for human beings to arise, just 6 million years ago. To give us an idea of the time which has passed until our first steps, Carl Sagan made a time comparison in which, if the age of the universe was a year, the Big Bang would have occurred on January 1st. On September 8th, the Sun would have formed. On September 11th, the Earth would have formed, and we would have been born the last day of the year, December 31st, at 11:39. How many things must have happened in other places during the same time?
Today, when we take a look at what we know about the universe and what we know about the origins of life on this planet, it leads us to think that the same things that happened here might well have happened elsewhere. And so life beyond this planet is quite plausible in terms of the science that we know today.
We see the organic building blocks that are essential to life on Earth. And so the raw stuff that's necessary for life is out there. The places that life could live is out there. The big question is, do they come together and form a second Genesis?
We take up a tiny place in the immensity of the universe. The Milky Way, the galaxy we live in, might have around 100 billion stars, among them our Sun. In total, it measures around 100,000 light years in diameter.
Maybe there are a million, maybe there are a billion, maybe there are 100 billion planets in the Milky Way galaxy that could support life, the kind of planets that earthly life could survive on. How many of them have cooked up their own life?
Here, from one end of the Milky Way, we, an intelligent civilization, wonder if it's possible that we are alone in all of this vastness.
There's just a lot of real estate, a lot of room for life in space. We've now learned that planets are as common as cheap hotels. They're all over the place. There are 1 trillion, that's 1,000,000,000 planets just in our own galaxy. If there is no life on any of them, then Earth is a miracle. A miracle. And I'll tell you this, for scientists, believing in miracles is usually not a good strategy.
When we think about how vast the universe is, it would be incredible if there's no other life out there. There are hundreds of billions of stars in our galaxy alone, and there are billions of galaxies in the universe. If life appears on only a minuscule fraction of those planets, then life is prevalent throughout the universe.
That's why human beings, in their enthusiasm for knowledge and exploration, have started the search for intelligent life, with the hope of, sooner or later, finding it, or being found by it.
Oiknis poteste chairete, Eirenikos pros filus eleluthamen filoi.
Paz e felicidade a todos. تحياتنا للأصدقاء في النجوم يا ليت يجمعنا الزمان.
Բոլոր անոնց, որ գտնվին եզերքի մի կամազություններեն անտին, ողջույններ.
पृथ्वी ऊपर वसनार एक मानव तरफ थी ब्रह्मांडના અન્ય અવકાશમાં વસનારાઓને હાર્દિક અભિનંદન. આ સંદેશો મળે વળતો સંદેશો મોકલાવશો.
This search can be done in two ways: tracking signals that may come from any extraterrestrial civilization, or sending our own messages into space, which may be received by one of those civilizations someday.
Active SETI, also sometimes called METI, messaging extraterrestrial intelligence, reverses the roles. Instead of passively listening for a signal from another civilization, we send intentional, powerful signals to nearby stars in the hope of getting a reply back.
With this goal, in 1977, the most elaborate and comprehensive message to date, The Sounds of the Earth, was launched into space. A moving introductory message including everything that human beings considered that an extraterrestrial civilization should know about our species. It was included on a golden record on each of the Voyager interstellar space probes, launched that same year from Cape Canaveral.
It was a golden record. On one side, there were encoded music from around the world, greetings in 55 languages, a 12-minute sound montage of the evolution of life on Earth. And on the other side, there were pictures, over 100 pictures describing some basic mathematical principles and the diversity of life and culture on Earth.
The content of the recording was carefully chosen by NASA and a committee chaired by astronomer and author Carl Sagan. The audio section has a salutation in English from the UN General Secretary and short messages in 55 languages, welcoming and wishing peace to all forms of life.
Witajcie, istoty z zaświatów.
Hello from the children of planet Earth.
But that one was not the only message sent.
There have been a few symbolic transmissions to other worlds. The most famous transmission to another civilization happened in 1974 from the world's most powerful radio telescope in Arecibo, Puerto Rico. It was a very simple message. It took 3 minutes to send, and it provides a mathematical and scientific overview of life on Earth.
Nevertheless, the search for extraterrestrial life is not founded just on the sending of messages in the hope of a response someday, but on the development of a search for signals that may indicate the existence of that intelligent life.
SETI, as a scientific exploration, actually got its start within NASA in the life sciences portion of NASA. People were interested in the question of life beyond the Earth. And this program developed within NASA. It launched actually in 1992. It was called the High Resolution Microwave Survey. In 1993, Senator Bryan from Nevada terminated NASA's funding for SETI, and he terminated with a vengeance so that NASA was unable to recover and come back the next year with another SETI program. So at that point, because we had already formed a nonprofit institute called the SETI Institute to help NASA stretch its funds as it did this SETI work. In 1993, we said, okay, we've got a nonprofit. We're just going to go out and raise money to do this privately.
The SETI Institute is nowadays the main world institution devoted to the search for extraterrestrial intelligence.
It's a project called SETI, the Search for Extraterrestrial Intelligence.
This search is based on the use of radio telescopes. Radio telescopes receive radio waves. As we can't go to space aboard spacecrafts to find that intelligent life, what we look for are radio signals.
What we're looking for is a signal that's at one spot on the radio dial. Just like when you're listening to the radio in your car. You know, you tune across the dial, you hear static everywhere, and then at one spot you're near, and there's a station. Okay, that's the signal that's produced by a transmitter somewhere. It's not natural static. It's not like a quasar or a pulsar or galaxies or hot gas, cold gas. All those things in space make radio noise, but it's all over the dial. So we look for signals that are at one spot on the dial, and of course the source of the signal has to be up in the sky. Those are the kinds of criteria we use to know that even if we don't know what it means, we at least know they're there. They're on the air.
One of the biggest SETI projects, started in 2007, is the Allen Telescope Array, which seeks to install 350 antennas to receive possible messages from outer space.
We designed this We went to Paul Allen and asked him to fund it, and he was generous to fund the first phase of construction of what we now call the Allen Telescope Array. It's in Northern California near Mount Lassen. The Allen Telescope Array has 42 telescopes. Someday we hope to grow it to 350.
The Allen Project will become the most powerful instrument in the search for signals from other civilizations in our galaxy. Since it was launched, after just a few months in operation, it has been able to analyze the same amount of area of the universe as in the last 45 years of SETI's existence. Another of SETI's most famous innovative projects is SETI at Home. It was started in 1999 by astronomers at the University of California in Berkeley, and it uses an army of millions of amateur internet users. From home, anyone can be part of this enthralling pursuit. The screensaver analyzes some of the data that comes from the Arecibo radio telescope in Puerto Rico. Up to now, more than 5 million people from all over the world have participated and are processing all of the info captured by the Arecibo radio telescope. The SETI at Home project has grown so quickly that it is the biggest ever of its kind. Both projects, Allen Telescope Array and SETI at Home, have been a huge advance in the search for intelligent life, giving hope for discoveries in the near future. But undoubtedly, what has radically revolutionized and pushed the search for extraterrestrial intelligent life is the Kepler mission, which is focused on the search for potentially inhabitable planets. It was launched by NASA on March 6, 2009, and orbits the Sun looking for extrasolar Earth-like planets where life may be possible.
Kepler, which is a space-based telescope that was launched about 5 years ago, is on the hunt for planets. Kepler has found literally thousands of planets or planetary candidates. It's a planet-finding machine.
The Kepler spacecraft has been a game changer in the search for other intelligence. Kepler now can tell us which stars have planets around them and which of those stars are Earth-like. That means we now know where we can point our telescopes to look for a twin of Earth.
In 2011, for the first time ever, Kepler provided scientists with a census of the Milky Way. For the first time ever, we can calculate how many stars in the Milky Way could have a planet like ours. Around 1 billion.
So one of the big triumphs of astronomy in the last 2 decades is to show the majority of stars have planets. There are planets all over the place. There are more planets than stars.
According to the data, in the near future, millions of inhabitable planets may be found just in our galaxy.
What Kepler has shown is that maybe 1 in 5 stars has a planet which could have liquid oceans, a bit of an atmosphere. In other words, the kind of place where you might want to build yourself a house, right? So 1 in 5 means that just in our galaxy, there are tens of thousands of millions of cousins of the Earth. That's a lot of real estate.
This data is crucial to answering the question of whether we are alone in the universe and helping us to resolve some unknowns of one of the most famous equations in astrophysics, the Drake equation, which is now of major interest.
The Drake equation is a way to grapple with all of the issues most central to determining how many civilizations are there out there in our galaxy trying to make contact. The Drake equation looks at 7 independent factors and tries to put a number on each of them.
So you multiply all those up, and you come up with a number that we call N, the number of potentially communicative civilizations in the Milky Way. Our star is the rate at which stars have been born in the Milky Way galaxy over the last few billion years. So it's a number that is stars per year. Our galaxy is 10 billion years old, and early in its history, stars formed at a different rate. All of the F factors are fractions. Each one must be less than or equal to 1. F sub p is the fraction of stars that have planets. N sub E is the average number of habitable planets in any planetary system. F sub L is the fraction of planets on which life actually begins, and F sub I is the fraction of all those life forms that develop intelligence. F sub C is the fraction of intelligent life that develops a civilization that decides to use some sort of transmitting technology. And finally, L, the longevity factor. On average, how many years do those transmitters continue to operate?
That is perhaps the most elusive term of the Drake equation. As we look into our own future, we wonder, will we survive as a technologically adolescent civilization? Will we last long enough to make contact? That is the big unknown.
The Drake equation includes a series of terms whose value we can't know exactly.
It's just a fantastic framework with which we can organize our ignorance, because you can't solve the equation. There are no right answers to that equation, not yet.
As we shift into the more biological and cultural terms of the Drake equation, we move into areas where we're uncertain.
But during the last few years, we've seen how exoplanets have arisen in front of our eyes, thanks mainly to the Kepler space satellite.
When Frank Drake first wrote down the Drake equation back in 1961, he put his own personal estimates into each of those factors and came up with a number, his estimate, which was 10,000. So within the Milky Way galaxy of 100 billion stars, he thought 10,000 of those stars might host technological civilizations.
What do we know now that we didn't know in 1961? Well, we know one or two of those terms a little bit better. And they kind of agree with the optimistic estimates that were made 50, 60 years ago.
There are other estimates that are extremely pessimistic. There's only one, and it's us. Carl Sagan had a number that was more optimistic. He said probably 1 million was his guess. We think we know that R star and N sub E are both numbers that are closer to 10 than, say, to 1. And all the F factors are less than 1. Some of them may be much less than 1. But of all these unknowns, the biggest unknown is L. So perhaps the most useful version of the Drake equation is simply to say that N is approximately equal to L. The information in this equation is very clear. Unless L is large, N will be small.
And these are estimates just for our galaxy. But we don't have estimates just for our galaxy, but for the visible universe. This fact multiplies the chances for the existence of extraterrestrial intelligence. The Hubble Space Telescope has given us an approximate calculation of the total number of galaxies in the viable universe. 100 billion. So we can calculate the number of Earth-like planets in the visible universe. 1 trillion Earth-like planets. The universe is 14 billion years old, so there has been time enough for intelligent empires to arise and possibly fall. It would be miraculous if no other advanced civilization anywhere had ever existed. It's just a matter of time until we find them. Radio telescope technology is becoming more and more advanced, and some scientists believe that the first evidence will be found in the next decades.
So far, we've looked at a little over 10,000 stars very carefully with the Allen Telescope Array. In the next couple of decades, that'll be 1 million stars. And by the time you've looked at 1 million stars, that's a reasonable number to find intelligent life, if it's really out there.
In fact, people like Craig Venter and Daniel Cohen have said 20th century was the century of physics. 21st century is going to be the century of biology. But my colleagues and astrobiologists and young scientists are saying, yes, the century of biology on Earth and beyond. This coming century, this 21st century, could well provide us with evidence of life beyond Earth and a biochemistry that's different from the only one we know.
The chance of an imminent discovery brings with it a controversial question. What will the first contact be like? What could human beings say to another intelligent species? What introductory message can we compose about human beings, that species that inhabits one of the edges of the universe, and who have developed enough to wonder if there is anyone else out there, or to try to find them?
There should be a deliberative process to think about how we want to present ourselves to other worlds.
And that is a dynamic conversation that we're having now in the science community. Should we transmit? If we do, who should speak for Earth? What should they say? In what language? How?
It's not a simple task to ponder our first introduction to an extraterrestrial intelligence, and the even more complicated question of how to compose that message to make it understood.
How we would say something meaningful to another civilization. It is going to be one of the most tremendous intellectual challenges humankind has ever faced.
Composing a message that can be understood by aliens will be extremely difficult, and conversation may be impossible.
In order to make contact with another civilization and truly understand them, we have to find a language that any scientist who is engaged in SETI anywhere in the galaxy will understand.
This is what's called active SETI, or METI, messaging to extraterrestrial intelligence.
If you can build a radio transmitter anywhere in the galaxy, you have to know that 2 + 2 = 4. And so it's basic mathematical principles like that that we use as the foundation for a language to communicate with extraterrestrials.
In terms of the message content, how it should be sent and what it should say, what would we say about ourselves? And what are efficient encoding schemes, and how do we provide a tutorial so that they can figure out what the scheme is?
My suggestion is to send the internet, right? Send so much information that they can look through it and find pictures, videos, sounds, text, of course, and they'll be able to understand it, sort of like the hieroglyphics.
Several messages have already been sent to space, and we hope to receive an answer someday. The first sent message was attached to the Pioneer 10 space probe, launched by NASA from Cape Canaveral on March 2, 1972. A golden anodized aluminum plate designed by astronomers Carl Sagan and Francis Drake was affixed to the probe. It was a kind of an interstellar message in a bottle. On it, drawings of 2 human figures appear, one feminine and one masculine, with the image of the spacecraft behind them to show the proportion of the human silhouettes. Our address in the universe was also included, as well as a scheme of our solar system. Another similar plate was affixed to the Pioneer 11. The next message, sent in 1974, was designed by the Dr. Frank Drake and transmitted by the Arecibo radio telescope in Puerto Rico. This message is generally known as the Arecibo message.
It was a very simple message. It took 3 minutes to send, and it provides a mathematical and scientific overview of life on Earth. It starts with a description of our numbering system in a binary code, numbers from 1 to 10, and then using those numbers, a description of chemical elements that are essential to life on Earth. And once we can talk about those chemicals, we can talk about the way they combine into molecules, including DNA, the core of our genetic material here on Earth. The Arecibo message also gave a description of our solar system, the population of our Earth, even a diagram of the telescope that was used to transmit the message.
1977 saw the launch of the Sounds of the Earth, the most elaborate and comprehensive message to date. Recorded on golden records, they were affixed to each other on the Voyager spacecrafts. Besides salutations in 55 languages, they included an audio section devoted to the sounds of the Earth. Volcanoes, lightning, wind, laughter, and the message in Latin, per aspera ad astra, through hardship to the stars, in Morse code. Also included were eclectic selections of music from different cultures. The Brandenburg Concerto No. 2 by Bach, the Magic Flute by Mozart, the Melancholy Blues by Louis Armstrong, Beethoven's Fifth Symphony, as well as traditional music from different cultures. In addition to the audio, 116 photographs were sent showing different forms of life on the Earth and human society, mathematics definitions, the structure of DNA, a diagram of the fertilization and birth, a violin with musical notes, and so on. Will anyone receive these messages? Will we have an answer? But above all, what will those who receive this message be like?
I think that one of the best things about finding life, a second Genesis, life that isn't related to us, somewhere else will be to begin to understand how biology can be different.
I mean, we don't even know if they'd have the similar biochemistry. But on the other hand, you know, we're carbon-based life forms, and carbon, which is all over the universe, of course, is great at hooking up with other atoms to make complex chemistry, and since that's what we are, you know, they might be carbon-based. That's not crazy.
We're having a hard time figuring out what other ways there might be. We're working on it from the bottom up with synthetic biology, trying to build life in other ways. But I think life elsewhere will have evolved to be perfectly suited to its environment. If the environments are similar to ours, then there could, in fact, be a lot of similarities. If the environments are extremely different from those that we enjoy here on this planet, then I think it's unimaginable. I'd love to find out what we can't imagine.
In fact, as we imagine the kind of beings we make contact with, they may not be biological beings at all. On Earth, we are anticipating computers becoming advanced enough that they may even deserve the term intelligence in the next century or so. So if we make contact with a civilization that's thousands or millions of years more advanced than we are, the intelligence on the other end of the line may be an artificial intelligence.
These hypothetical forms of life may have abandoned their biological bodies a long time ago to create a computer body. They may have the ability to build a quantum computer with an extraordinary computing power, a super-intelligent device with the same capacity as a conventional computer that occupies a whole planet. Then, they may have lost their consciousness of the self to be absorbed by a global digital network of minds, a great collective consciousness.
But in terms of what they'd be like, what they'd look like, nobody can really say, except this. Probably within 100 years, we're going to develop thinking machines here on Earth. So I think it's very likely that if you actually pick up a signal coming from elsewhere, it's not coming from some sort of biological being, it's coming from a machine.
The search for extraterrestrial intelligence is not really different from the search for our own future. The absolute ignorance about the possible aims of an extraterrestrial intelligence is what has led some scientists to voice their misgivings about announcing our existence to extraterrestrials, at least until we know their intentions toward us.
Active SETI is a controversial topic. No less than the cosmologist Stephen Hawking warned, do not transmit to ET. When he said that in 2010, his concern was that aliens may invade Earth to strip mine our planet, taking our rare resources. Well, Hawking is a genius, but he can't predict the future. And so there's no way he could have told that Earth-like planets are distributed everywhere. But even if there is a danger, even if another civilization can come to Earth, it's too late to conceal our existence. Any civilization with the ability to travel between the stars can already pick up our radio and TV signals that are leaking off into space. There is no added danger of transmitting signals through active SETI.
In any case, considering the data we now know, a first contact may be possible in a short time. It's also possible that some civilization has already listened to our messages. Nevertheless, how is it possible that if there are other civilizations, we haven't yet received any evidence of their existence? This is what is known as the Fermi paradox.
The physicist Enrico Fermi famously asked, where are they? The idea was, if in fact the universe is populated with life, why haven't they come here?
The formulation of that paradox arose when the physicist Enrico Fermi was working on the Manhattan Project, whose aim was the development of the US atomic bomb. Fermi's answer to his paradox was that every advanced civilization develops, along with its technology, the potential to exterminate itself, as was thought to be happening at that time. The fact that other extraterrestrial civilizations had not been found implied for him a tragic end for humanity. However, there are several possible solutions to the Fermi paradox. They do exist, but they are not communicating with us. They do exist and communicate, but we can't hear them. They do exist and have been here, but we weren't. They do exist, but most people don't know it yet. They have disappeared. Maybe these civilizations have already destroyed themselves as a consequence of a nuclear war or some other cause. But we find even more solutions to the paradox.
Well, there are a lot of answers to the Fermi paradox. One is that it's actually very difficult to travel between the stars. Even over the course of long periods of time, it takes a lot of energy, it takes a lot of commitment, and anything that you can gain in terms of information, you could get a lot cheaper simply by sending radio signals.
Another possible solution is that we aren't interesting to them. If some civilization were able to come to the Earth from the stars, it would have to be thousands or millions times more advanced than ours, and we may not have anything interesting to offer them. Such a civilization might consider us as primitive, as we consider a simple beehive. Would it make any sense for us to interact with bees and try to make them understand our advances in spacecraft missions, nuclear energy, or quantum mechanics?
Or maybe there is colonization and we just don't happen to see it because it's not nearby or it isn't very obvious.
Paradoxically, the galaxy could be filled with intelligent forms of life, but we are so primitive that we have not even realized it. Another explanation for the Fermi paradox is that we may have already received those signals, but we haven't realized it. We haven't perceived the signals, or we haven't been able to understand or decode them. In this case, some strange signals from outer space have been received. Their origins are now being investigated, and they have posed serious questions for scientists.
The most famous signal that's been detected came in 1977. It was at Ohio State University's Big Ear radio telescope. And in the course of listening for signals from another civilization, there was this message that was strong, that was spread out over frequencies. It looked exactly like the kind of signal we would want to get from ET.
During his work on the night shift on July 15, 1977, Jerry R. Eman, professor of the State University of Ohio and SETI project volunteer, observed the weird transcription of the radio signal made by a computer in a section of paper feed to confirm later that it was the most intense anomalous signal detected up to that point by a radio telescope. The signal of unknown origin had a duration of 72 seconds and reached an intensity 30 times higher than conventional signals, and had come from the constellation of Sagittarius.
In fact, it was so astounding that when the technician was looking at the printout the next morning, he wrote "wow" in the margin, and that's become known as the wow signal.
The computer processed the signals received into a series of alphanumeric characters. It wrote the sequence 6EQUJ5, which has kept the international scientific community on edge until today. Eamon and his team studied the signal in detail. In the end, they were able to rule out that it had been part of any interference coming from the Earth. So during the following month, the operators of the radio telescope tried to reposition the signal, but they didn't succeed.
Well, many times in the decades since then, astronomers have looked at the same part of the sky to see whether they can find the wow signal again, but we've never been able to replicate it. So the key to progress in SETI is to be able to find a signal that looks as good as the wow signal, but now to be able to find it not just once, but over and over and over again.
Today, the origin of that signal is still under investigation. Another signal which provoked important debates was the radio source SHGB02+14A, discovered in March 2003 by SETI at home and announced in New Scientist on September 1st, 2004. Since SETI at home started, more than 5 billion signals have been detected that, because of their mathematical profile or their lack of repetition in time, have been ruled out. Among all of them, the candidate SHGB02+14A was one of the very few that was confirmed again, and the only one to maintain a high statistical chance of being intelligent and of extraterrestrial origin. Another relevant signal was the one observed by the Australian astronomer Regbur Bathal, a SETI collaborator, who found a strange signal close to what years later would be confirmed by NASA as the first habitable planet, the Glycel 581, just 20 light-years away. On the NASA website, in the section Astrology Picture of the Day, we found an explanation for the signal. No one knows for sure what caused this signal. There is a slight possibility that it just might originate from an extraterrestrial intelligence. Many unusual signals from space remain unidentified. The study of signals possibly emitted by an extraterrestrial intelligence is a delicate matter that requires a great deal of confirmation.
First, if you think you have a signal from an extraterrestrial, make sure, check with colleagues, double check your data. And then secondly, if you're really pretty sure you found it, tell the whole world.
Despite countless conjectures about a possible contact or some evidence that is being hidden, SETI states that we haven't yet received a confirmed signal and makes it clear that as far as SETI is concerned, it wouldn't be a piece of information to hide.
A lot of people in this country figure the federal government would cover it all up because the public couldn't handle the news. Well, we know that isn't true because we've had false alarms. And what actually happens is the media are very interested. The newspapers, the radio shows, TV shows, they call you up right away if you get any kind of interesting signal.
So according to the SETI protocol, the day they confirm the first signal indicative of extraterrestrial intelligence, they will make the news known worldwide. A fact that, considering technological advances, may occur in a short time. Seth Shostak declared before the House Science Committee of the American Congress that in a couple of decades, we will have found evidence of its existence.
The chances of finding it, I think, are good, and if that happens, it'll happen in the next 20 years, depending on the financing. There are sort of guesses as to how many societies might be out there broadcasting, and those guesses run from maybe 10,000 to 1 million. Well, if the correct number is anywhere in that range, then we should find something within a few decades. So, you know, this is not like building cathedrals in the Middle Ages. This is something that's going to work within one generation if it's going to work at all.
If I had to bet, when we will find intelligence beyond Earth, I'd say in the next 20 years. And it's simply because technology is advancing all the time. SETI success depends on computing power.
What will happen from then on? What will occur when we receive a signal and it is confirmed as extraterrestrial? How would that affect our lives, our priorities, our conception of the world, and our own identity? Is humankind prepared?
So what happens if we find a signal? If we find evidence that they're out there, you know, people will still go to work the next day, or if they're in school, they'll still go to school. They won't divorce their spouses. There won't be civil unrest. They won't be rioting in the streets. It's just that we will know something really important, that as wonderful as Earth is, as wonderful as our species is, we're not the only kids on the block. And I think it's good to know that if it's true.
In January 2010, the Royal Society held a conference entitled The Detection of Extraterrestrial Life and the Consequences for Science and Society. The introduction of the conference was as follows. Astronomers are able now to detect planets where life may exist, and the living generation could see the signature of extraterrestrial life being detected. Should it turn out that we are not alone in the universe, it will fundamentally affect how humanity understands itself, and we need to be prepared for the consequences.
Over the long term, if you actually did get a message and could understand it, of course, that could be very transformative. Imagine, you know, giving, I don't know, Neanderthals the keys to your local library. Say, hey, you might want to read some of this stuff. I mean, that would change everything for them. So there is that potential, although I think it's a fairly far-fetched idea.
Concerned that a discovery could be close, humankind has slowly started to prepare itself to establish a protocol procedure. Neither a country nor a collective of people would be represented, but all of humankind.
There's a protocol called the Declaration of Principles Concerning Activities Following the Detection of Extraterrestrial Intelligence. And this provides guidelines about what do we do next. The most fundamental issue raised in this protocol is before there is a reply, there should be broad-based global discussion. That if we are to speak to another civilization, if we are to send a response, it should be a response that has gathered global input. This wasn't transmitted to the SETI Institute or to any other organization. The message was transmitted to Earth. It belongs to the whole Earth. It should be shared widely.
Most scientists agree that a finding like this would alter and transform the status quo in many ways. What would be its effect on our society, our science, our technology, or our religion?
So for me, detecting another civilization is a way of coming to a better understanding of who we are as human beings. It would mean a chance to see whether the ways of knowing that we've developed here on Earth, our math, our science, our ways of expressing ourselves, our music, our art, are they somehow tapping into something that goes beyond Earth, or are they uniquely ours?
The discovery would be on the same level as those of Copernicus and Darwin, and as of the transforming events in human history. However, it will be decades before people get used to the idea that we are not alone in the universe, and its real meaning becomes deeply ingrained, as occurred with the heliocentric cosmology and biological evolution. It's likely that our first contact with an extraterrestrial civilization will happen when the Allen Telescope Array detects a message that confirms, at last, the existence of extraterrestrial intelligent life, or when one of the people connected to the SETI at Home project announces that his computer has decoded some of the signals of the Arecibo telescope. Then, our first contact will be a unidirectional conversation. We might capture some intelligent message by chance, but it could take decades or centuries before our answer gets to them, given the huge distances of the universe.
Let me tell you what my hope for the impact of the detection of a distant technology would be. What I hope is that we can make it understood to the people on this planet that the only way that contact happened was because, on average, technological civilizations have a long lifetime. We're sitting here as a very young technology, and we literally do not know whether it's possible to grow old, to be able to be wise enough to manage our population, to shepherd our planet, to go forward into a long future, long in cosmic times. But if we find someone else, we know the answer to that question. We get a proof of existence. It's possible to grow old. Somebody else figured out how to do it. And I would hope that that would motivate us to find solutions to the problems that we face today. We know that somebody else made it through this bottleneck, this technological adolescence. I'd hope it would motivate us to find answers for ourselves.
Today we know that the first contact may occur in not too a long time. It's not easy to figure out what will happen in this first communication, if it will be something positive or harmful to human beings. What is clear is that it will be a turning point in the life of the human species.
In the 21st century, one of the greatest achievements in history still remains a source of controversy.
It's one small step for man, one giant leap for mankind.
Did the Apollo moon landings really happen? Or were they the biggest hoax of all time? Trevor Weaver has dedicated years of research to the Apollo missions and was once a supporter of the moon landings.
We didn't go to the moon, and that is an established fact. NASA provided all the topographical data they had, all the photographs, all the massive models to Stanley Kubrick, so they could actually fake moon scenes.
Could the moon landings actually have been faked by Hollywood director Stanley Kubrick? The history books say otherwise, that Apollo 11 astronaut Edwin Buzz Aldrin spent 3 days traveling to the moon and was the first to follow Neil Armstrong's historic footsteps.
Beautiful view. Isn't that something?
I'm totally in favor of freedom of speech, but I think people need to be responsible when they think about intentionally, for their own benefit, misleading the young people who are the future leaders of our world.
Moon conspiracy theorists have been a small but persistent and vocal group, over the years often confronting and accusing astronauts of lying. In 2002, when conspiracy theorist Bart Sibrel buttonholed Buzz Aldrin, his temper got the better of him.
You're the one who said you walked on the moon when you didn't. Calling the kettle black if ever thought of it. Saying I misrepresented myself.
Away from me.
You're a coward and a liar and a thief.
The punch stirred a generation less trusting of traditional media, more open to believing fake news and theories spread on the internet, and revived the moon landings hoax theories.
NASA never realized that we would have something called the internet. It's only now, when all those videos are available, that people can see what the problems are.
I think the propagation of so-called fake news, the spread, which is very welcome, of access to the internet, means that we have far more sources than we used to. There is a real crisis in understanding the strength of those sources. People often have some kind of distrust of authority, governments, and so on, and they assume that there's some kind of plot to keep the information from us, that actually the propaganda victory of going to the moon could be based on something that was entirely fabricated.
But if the Apollo missions were faked, it would mean NASA had managed to keep one of the biggest secrets ever created. 50 years ago, the Soviet Union and the USA were locked in a struggle for global dominance. Then, on October the 4th, 1957, the Soviets launched Sputnik, the world's first satellite, into orbit. A breakthrough that hit America hard and made the race to space even more crucial.
There's no doubt that the space race in the 1960s was driven by superpower rivalry. There was a degree of anxiety in the West about the advancement in Soviet technology, and the feeling that the West somehow had lost its leadership and needed to catch up.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
At the peak of the Apollo program, NASA employed 400,000 people. But was putting a man on the moon so important that the United States government faked it? If so, a legion of NASA employees not only participated in the deception, but they kept the secret from the rest of the world.
That was such a seminal event that it wasn't just about the mission itself, but the way that that influenced wider life. You know, people began to think, oh, we can do space travel, we can actually go to other worlds.
On July the 16th, 1969, the 3 Apollo 11 astronauts prepared for liftoff. But while the world eagerly awaited for history to be made, one man was already skeptical. During the 1960s, Bill Kaysing was the head of technical publications for Rocketdyne, the company that helped manufacture the Apollo rockets. Kaysing, who claimed he had access to some of its top-secret documents, questioned the competence of the Apollo project.
I really believe that they weren't in the command capsule at launch. They did a little bit of a magician act with the astronauts. They went up the elevator, but they came down the elevator. In other words, they did not want to risk the lives of the astronauts in case the Saturn blew up.
An explosive claim, which Kaysing said the CIA tried to silence by making 3 attempts on his life. Like Kaysing, Marcus Allen, British publisher of Nexus, a magazine of alternative politics, history and science, also questions NASA's engineering capability at the time of the launches.
The problem is the whole Apollo program was a complete fabrication in order to be seen to succeed in the Cold War. The myth of Apollo is what is holding NASA back from future space travel. It's a tragedy. We didn't go the first time, we can't go now, we've never been. They lied to us.
But if NASA didn't put a man on the moon, it would have had to fake the evidence. And its own visual images have done the most to fuel conspiracy theories.
Every photograph taken on the lunar surface is online, 5,771. Some of them are not particularly good, some are out of focus, some are light struck, some just don't show very much of interest, and some of them are very good indeed. And it's the very good ones I question. I do not believe they were taken on the moon. They were taken here on Earth.
Conspiracy theorists believe NASA faked all 6 of the Apollo moon landings and point to these NASA photographs as proof. Some of the most renowned claims suggest that areas lit from behind should be in dark shade, when in fact, they reveal full detail. In others, the shadows don't run parallel. Is this because they were lit by separate sources, suggesting film lighting? Despite being taken in space, no stars are visible in any of the Apollo photographs. Gravity on the moon is 1/6 of that on Earth, but when archive footage is sped up, the astronauts appear to be running at normal speed in Earth's gravity. And with no atmosphere on the moon, why does the flag seem to wave in a breeze? For the purpose of this program, we filmed an experiment on a lunar set built in the Trona Pinnacles in the Californian desert to challenge the hoax theories and put these claims to the test. By testing some of the most famous conspiracy arguments and addressing new evidence, can we put the lunar hoax theories to rest once and for all?
This is Apollo Control Houston at 105 hours. Now into the flight Apollo 11.
People all over the world were eagerly tuned in to the historic event.
Dass ein Mensch zum ersten Mal den Mond.
Astronomer Sir Patrick Moore reported the mission live on British television.
Ever since the dawn of human history, we dreamed about going to other worlds, and this was the first time it had been done. And of course it was an exciting time, and also a very tense one.
Five, 4, 3, 2, 1, 0. Liftoff. We have a liftoff.
There were some amateur radio enthusiasts who built a very large dish and were able to actually listen in to the astronauts talking from the moon's surface. They didn't hear mission control. They were able to pick up just the astronauts by themselves.
Ian Morrison witnessed the event from a unique perspective. A student at the Jodrell Bank Radio Telescope near Manchester, England, he took advantage of the facilities and listened in to the mission of his own accord.
I should say that we were not officially tracking the Apollo craft. We were doing this for fun and our own interest.
Houston, Apollo 11 entered and gave us a magnificent ride.
We could hear the whole conversation of the astronauts all the way down to the surface. They were obviously highly excited, and it must have been wonderful as they sort of literally reached the surface.
Out my left-hand window right now, I can observe the entire continent of North America. Okay, engine stop. We copy you down, Eagle. Tranquility Base here. The Eagle has landed.
And then Neil's voice came through, the Eagle has landed. And that for me was a minute of intense relief. And since I'm on the air live, I had to watch what I said.
That's one small step for man, one giant leap for mankind.
In 1969, the public had little reason to question mankind's historic first step on the moon. After all, the achievement was a celebration of technological supremacy. America had finally won the space race. Mankind's first steps on the moon have become the epicenter of hoax theories. Conspiracy theorists claim NASA faced a formidable challenge with its primitive 1960s technology. Just 14 months before the Apollo 11 mission, Neil Armstrong test-piloted a prototype lunar lander. The result was disastrous.
Unfortunately, it went out of his control, and luckily he was able to eject before it crashed in flames. If they couldn't get a simulator to work on Earth, how in the world could they get the actual lunar module to work on the moon?
And of course I knew both Neil and Buzz. There was no provision for rescue. Had they made a faulty landing, they couldn't have got back, and that would have been too ghastly to contemplate.
Conspiracy theorists question not only the technical capabilities of the landing craft, but also the computing power that guided it.
They didn't have the technology to do it. And the risk is too great. They could not afford to risk failure. They wouldn't allow themselves to rely on science and technology to get them there.
Pat Norris is a former space system and software engineer hired by NASA to analyze the challenges of navigating to the moon and back.
In the 1950s, computers didn't really exist. But by the mid-1960s, computers were available that were powerful enough to do the calculations needed for such a complicated mission. Of course, by comparison with today's computers, they were very primitive.
While these advancements should surely encourage a new line of missions, conspiracy theorists argue that this is enough to question if we ever could have gone in the first place.
We're talking about the mid-1960s here, when computers occupied rooms. The sort of computing power that you have in a mobile phone today would be greater than the computing power that was alleged to have been used to land man on the moon.
One of the reasons that we had difficulty in navigating close to the moon was that the computers available weren't able to provide a sufficiently detailed mathematical model of the moon's gravity. Perhaps there wasn't enough information, but even if there had been enough information, the computers probably wouldn't have been able to cope with it. They were adequate for the mission at the time, but only just.
Unlike modern-day PCs, the Apollo computers didn't have to store files or process images. Most of the number crunching was done at mission control, and the information transmitted back to the astronauts. In their attempt to disprove the missions, conspiracy theorists have analyzed the footage of the moon landings frame by frame. One of the most famous pieces of footage in history is Buzz Aldrin's dance across the moonscape.
Near the end of the 2.5 hours, in front of the television camera, I did have an opportunity to prance around and hop and demonstrate different methods of moving around. The movement, because of the restrictions of the spacesuit, was basically like being in slow motion.
The famous lunar walk shows Aldrin experimenting with the restrictions of the spacesuit.
So-called kangaroo hop does work, but it seems your forward ability is not quite as good.
Conspiracy theorists have claimed that the footage was actually filmed in slow motion in a studio, and that the astronauts were supported by wires to replicate these movements on the moon.
The astronaut is dangling on a wire to take off, if you like, the difference between the Earth's gravity and the moon's gravity. The wire was between the backpack and the body. The problem is the astronauts tended to rely on this wire, so you see lots of jerky movements.
Astronauts were wearing pretty big and bulky spacesuits, and the weight distribution isn't the same as you or I walking around on the surface of the Earth here. The astronauts had to really cope with that and work out if they're top heavy, how to move around such that they weren't going to fall over all the time and be unbalanced.
You do have to be rather careful to keep track of where your center of mass is.
You can see that astronauts really adapted really well to that and started to kind of develop this new walk.
While the exact conditions of the moon couldn't be replicated on Earth, NASA introduced methods to adapt the astronauts. One of their favorite methods was parabolic flight, or as the astronauts called it, the vomit comet. By climbing and diving in a series of arcs, an aeroplane could simulate 30-second windows of reduced gravity. These sessions served as road tests for the spacesuits and gave astronauts their first taste of lunar gravity. If, as the conspiracy theorists claim, NASA faked the Apollo missions, then it also had to fake the photographic evidence.
I was trained as a photographer in London back in the 1960s. I was familiar with the camera that was used, the Hasselblad camera, and also with the film that was used, Kodak Ektachrome transparency material. So I was familiar with the technical side of it. And the more I looked at the photographs, the more I started to doubt whether what we'd been told had actually happened the way we'd been told.
Also siding with Marcus, American conspiracy theorist Ralph Rene raised a different technical question. Could the gloves the astronauts wore on their pressurized spacesuits have actually worked on the moon?
What I do is I pull a vacuum in this chamber I created, and I have a glove inserted inside of it, and it was to prove that the flexibility they shown in their suits and gloves are impossible. Right now, I can put my hand in there and I can move it every which way. I can grasp, I make a fist, I can lift up, down. But as soon as I throw this switch here, I evacuate the chamber.
As air is sucked out of the machine, the vacuum makes it more and more difficult to move the glove.
And this glove doesn't want to move. I can't bend it backwards. I can hardly force it down. I mean, how could you pick up small screws and bolts like they've shown them to do, or trigger a little tiny trigger on a camera with the glove doing this?
If it seems impossible to operate a camera properly in pressurized gloves, how could these perfect pictures have been taken? Trained aerospace engineer Jay Windley has extensively researched the moon landing conspiracies and was present at the experiment on the moon set to refute these theories.
This is a Hasselblad EL500 camera manufactured specially for the lunar missions. It attached to the spacesuit via this bayonet. The camera would have a framework surrounding the bottom and rear of the camera, and it would slide down onto the control unit here so that the astronaut could work with his hands without worrying about the camera.
Lunar cameras didn't have a viewfinder because the astronauts' helmets prevented them from looking down and framing the shot.
Basically, you could just sort of point that camera at what you wanted without having to really look through a viewfinder.
But according to conspiracy theorists, this was a problem that couldn't be solved.
They had to focus it, set the shutter speed, set the aperture by hand, wearing armored gauntlets. And you can't see the shutter button on a Hasselblad, it's on the front of the camera. You didn't know if you'd taken a photograph because you can't hear anything in space, and you can't see the counter diodes on the side of the camera. So with all those restrictions, we have some of the most iconic images ever taken in the 20th century. I don't believe it.
I'll step out and take some of my first pictures here.
Jay Windley investigated how these design features on the Hasselblad would have been operated by the astronauts.
The Zeiss Biogon lens here has been fitted with these little paddles to allow the astronaut to manipulate them with clumsy fingers. You just push it in either direction. The shutter release, normally a very small button, has been made especially large so that it can be pressed with an astronaut's glove. The focus ring has been fitted with stops that correspond to near, medium, far, and infinity. So he didn't have to pay attention to whether he was 8 feet or 9 feet away from a subject. He wouldn't have to very carefully measure it.
Richard Underwood was responsible for teaching Apollo astronauts the art of lunar photography.
Even in the early days, before they went to the moon, I'd say, you know, when you get back from this journey, you will be a national hero. But your photographs, I say, if they're good, they'll live forever. I'd tell them your only key to immortality is the quality of your photography. Nothing else. Forget all the other stuff.
The astronauts were told to take their lunar cameras everywhere they went and practice.
They took them home to photograph their friends and family and barbecues and sporting events and all other types of things. They knew that camera very, very effectively.
All of the crew members understood pretty well how to operate this, and the film turned out to be very, very versatile in coming up with just outstanding results.
But these outstanding results led to one of the most famous photographic anomalies, the strange case of the lunar shadows.
The shadows are one of the strong proofs that we never went to the moon. If you examine pictures offered by NASA as genuine, you find that in many cases the shadows are not parallel. Well, since the sun was the only source of light, all shadows on the moon should be exactly parallel, but they aren't.
Because the lunar shadows fall in different directions, some conspiracy theorists claim that they were created by separate artificial light sources.
There's only one sun. There are not two. But these shadows are anomalous in that sometimes they are diverging from objects and sometimes converging. And it can't be. You can go any place on this planet when the sun's up and you look at two objects and those sun shadows are parallel.
But according to physicists, there are reasonable explanations for why we find that shadows aren't always parallel.
There's lots of different things which can make shadows go in different directions. I mean, obviously you have shadows pointing away from the sun, but if your camera is a wide-angle camera, you'll get a perspective effect on the shadows.
The effect of converging shadows is a well-known optical phenomena in photography. This effect is created where there is a single light source. For both the moon and the Earth, this source is the sun.
If you have bits of topography on the surface, like troughs, they can produce shadows which appear to be at right angles to the main direction of the sun.
But if we look at the photos, Aldrin appears to be brightly lit up. shouldn't the astronaut's body be in darkness?
He's standing in a pool of light. It's a spotlight. It's not the sun. This is taken here on Earth under controlled studio lighting conditions with a whacking great, probably a 12K Arri spotlight.
On the moon, you're not just illuminated by the sun shining towards you and casting a shadow behind you, but there's also a huge area of the lunar surface around you, and that provides backlight to any subject on the moon's surface. You can also get reflections of light off bright objects like spacesuits, if they're fairly close to whatever they're illuminating.
And specifically, the light bouncing off the highly reflective lunar module. In these pictures, you can clearly see where a pool of light appears. If you look at pictures where the astronauts are away from the module, the surface appears evenly lit. Another cause for suspicion among conspiracy theorists is Apollo's symbolic highlight, the American flag.
Wherever there's an American flag, it's always brilliantly lit up, even if it's on the shadow side. And on the shadow side, that should be really dark black. But they had little spotlights, obviously, because that's the only way you can do it.
Oh, geez, that's great. Is the lighting halfway decent?
The flag they took to the moon was made of nylon, which is fairly translucent material. It lets light through, so I wouldn't expect to see one side bright and one side dark.
Here we can see our flag brightly lit from the front, but if we move around to the back, we can see that even with our single light source, it's still brightly lit. The light is shining through and making the flag glow.
But why does the lunar flag wave around if there's no wind on the moon?
The stage sets were very hot, because when you film in slow motion, you need more light, because each frame is being exposed. They had 144 frames per second, so they needed very, very strong lights. Therefore, it was probably very hot. Probably they had some cooling.
Is this waving flag the ultimate proof the landings were faked in a studio? With no atmosphere on the moon, the planting of the Apollo flag has caused some controversy.
If you look at how the flag swings, the edge of the flag is acting like a pendulum. If you know the length of the pendulum, you know the time of the swing, you can say where the gravity is, and it was on Earth.
So how could the flag, flapping on the windless moon, be explained? Neil Armstrong and Buzz Aldrin may not have been thinking about that question as they prepared for the historic moment.
Putting the flag on the moon was really a symbolic highlight of the mission. It was one that we had not really rehearsed. Neil knew where the flag was stowed. We brought it out, then we had to put the two pieces together.
It won't go up. Fade that end up.
The astronauts had to drive the flagstaff into the hard lunar surface with a twisting motion. A horizontal aluminium rod kept the flag suspended.
And this caused the free end of the flag to flip up and back in response to that. Also, this is an aluminum tube, very similar to the ones used on the Apollo mission. It's very springy. If I cause it to spring and then let go of it, we see that this motion continues long after I've let go of it.
Once it's in the surface, then those oscillations gradually dampen away over time, the vibrations going down the flagpole, and then it's pretty much stable after that.
Beautiful, just beautiful.
Conspiracy theorists point to another strange anomaly, one that can't be explained by lack of atmosphere. As the 16-ton landing craft touched down, its powerful rockets would be expected to blast away the top layer of dust, exposing the rocky lunar surface. But footprints were visibly photographed beneath the spacecraft, and there seems to be no dust on the landing pads.
One of the problems that was encountered, of course, is lunar dust. The moon is covered with it. And in fact, prior to landing on the moon, they'd sent unmanned landers. One of the concerns was the fact the lunar surface might actually be so dusty that any spacecraft that tried to land on it might actually sink in it. And if it wouldn't support an unmanned probe, it certainly wasn't going to support a manned one.
Ralph Rene devised an experiment to illustrate his notion that the rocket-powered lander should have left a crater. If a garden leaf blower, which is dramatically less powerful, can move dust with Earth's gravity, Why didn't a rocket which produced 10,000 pounds of thrust?
They didn't move dry dust, they didn't move little rocks, they didn't move anything. So the demonstration is to show that this stuff will disappear immediately, and I'll even be able to gouge some kind of a hole.
If René is correct, the lunar surface, like the gravel pit, would show visible signs of disturbance.
But when it actually landed, the dust was all still there. Now, how can that be? You know, if you blow dust away, it goes away, like I just did here. I swept the ground.
Some people think that when you land on the moon, you should get a very big crater underneath the rocket nozzle on the lunar module. Now, that's not the case, because when they were coming in, they'd already throttled down to at least about a quarter of the maximum thrust. And just above the surface, they turned off the rocket motors. So any exhaust was actually pretty feeble when it landed on the moon's surface.
Descent engine did not leave a crater of any size.
If you look at the pictures, you can see a very slight depression underneath the rocket nozzle where dust and a little bit of soil has been radially blown away in different directions around the lunar module.
And a closer inspection of some of the photographs reveals that the landing did, in fact, disturb a very fine layer of dust, but not enough to cover the landing pads.
I can see some evidence of rays emanating from the descent engine, but very insignificant amount.
But the NASA images from the mission aren't the only proof of the module landing on the surface. Satellite images taken of the lunar surface in more recent years could suggest more compelling evidence of the Apollo landings. The Lunar Reconnaissance Orbiter is a robotic spacecraft launched by NASA in 2009 to orbit the Moon.
Using some very high-resolution cameras and being relatively close to the Moon's surface, it has actually been able to pick out each of the 6 Apollo landing sites. And not only the descent stages where they landed, but locations of the flags, the experiments, the 3 rovers that were left on the last 3 missions.
But some argue that these satellite images aren't as detailed as they expected when they were taken in 2011.
The Lunar Reconnaissance Orbiter was deliberately flown over what is purported to be the Apollo landing sites, and from a height of 12 miles, i.e. not very far at all, what do you see? A couple of pixels. If you looked at these images without NASA putting on a whacking grey arrow, you wouldn't know what you're looking at.
While satellite images of the equipment left behind may not be detailed enough to persuade some, there are other markers of man-made interference in the images.
I have to say, what you see is just 1 or 2 pixels, but you don't get a sharp picture, a nice clean picture of the lunar module. But the LRO pictures do show some discoloration of the area where the lunar module took off, so that seems fairly consistent with what NASA said.
Alongside the lunar reconnaissance images, evidence from other missions have also been able to confirm the Apollo landing sites.
Altitude 4200. Houston, you're a go for landing, over.
Of course, we've also had the Chinese and the Japanese with their own lunar missions. They are able to image the areas in which the landings took place, and there are evidence of soil disturbance. So you do have that third-party verification that the landings themselves took place.
There's one more big question conspiracy theorists ask about the Apollo 11 photographs. With no weather on the Moon, you would expect a spectacular view of space. Yet, there are no stars in the Apollo photographs.
Some of these conspiracy theories, they think that if you go to the moon, you should be able to see stars because there's no atmosphere there, so space should be nice and black, so you should be able to see a lot more stars than are shown in the Apollo photographs.
Bill Casing is convinced this was a conscious decision on NASA's part.
If you were to talk to Aldrin or Armstrong or any of the other Apollo astronauts, they would actually not respond in any way to questions regarding stars.
When you looked up at the sky, could you actually see the stars and the solar corona in spite of the glare?
We were never able to see stars from the lunar surface or on the daylight side of the moon by eye without looking through the optics.
I asked Neil Armstrong whether he saw stars because I knew everybody else would ask it. I knew the answer, of course. The point is that their eyes aren't adapted to that.
The human eye reacts to light by opening and closing the iris. In bright light, the iris becomes smaller. In the dark, it widens. On the Moon, the eye, like the camera aperture, can't adjust to the brightness of the lunar surface and the darkness of space at the same time.
If you increase the aperture, you increase the amount of light going in. And if you increase the exposure time, you also increase the amount of light going in. Now, if you were to do that on the Moon to get the stars, then that would mean that the foreground would just be completely washed out and overexposed. When really what the astronauts were trying to take pictures of was themselves, the surface features of the Moon.
If you imagine going, let's say, to a football stadium and all the lights are turned out, and you look up at the sky, you can see lots of stars. Now, if you can imagine some person turned on a floodlight, it would drown out pretty much all the stars.
With the powerful light, even our own television camera can't adjust to the extreme contrast to see the stars in the sky. On our Moon set, Jay Windley puts this theory into practice in the hope of disproving one of the conspiracy theorists' recurring arguments.
We're going to find out that if we use an identical camera loaded with identical film and we shoot pictures of the night sky, we won't get stars. Okay, I'm going to take a shot here. You'll notice here I'm not using any sort of a viewfinder. I'm just aiming.
Will this experiment be enough to invalidate the conspiracy theorists' claims? The morning after the shoot, the negatives are developed at a professional processing laboratory in Los Angeles.
In our experiment in the desert, we shot a variety of photographs using different film formats. Like the Apollo astronauts, we had to guess at our focusing distances and our exposure settings. And because we had no viewfinder, we had to guess at the direction the camera was pointing. And you can clearly see that even with those handicaps, we were able to take quite usable photographs. You can immediately see that there are no stars in this photograph, even though the stars were very bright during our experiment. They're simply too dim to be registered on film at the exposure levels that we used to take these photographs.
Our experiment demonstrates that the stars could not have been seen in the photographs taken on the lunar surface. But this explanation doesn't satisfy magazine publisher Marcus Allen. He believes it's impossible that any of these photographs could survive a journey to the Moon and back in the first place.
Photographic film cannot withstand the vacuum of space. So how did they get all these fantastic photographs we've been shown forever about Apollo astronauts on the Moon when the film was not in a pressurized environment, let alone radiation protection?
Conspiracy theorists believe this is their trump card. Not only would it destroy film, it would kill the astronauts. The Earth's magnetic field protects our planet from solar rays. But beyond this zone, deep in space, is where conspiracy theorists believe astronauts would be vulnerable to radiation's deadly effects.
The Moon is irradiated by the sun constantly with terrible heat, and of course there's cosmic radiation, and then there are micrometeorites that travel 60,000 miles an hour that would go right through the camera, the film, and of course the astronauts themselves.
After leaving the Earth's atmosphere, the astronauts rocketed through the Van Allen belts.
Van Allen, he said it was a sea of deadly radiation. You would pick up a death dose just about the time you got through the Van Allen shield. You'd be cooked and you'd be dying.
These radioactive belts form a thick ring encircling the equator, thinning out around the North and South poles.
Until they get an engine that'll lift the life capsule surrounded by 6 feet of water or equivalent mass of lead, they don't even dare go through the Van Allen shield.
NASA knew it was dangerous. Don't you think that when they went through the Van Allen belts, they would have said, How are you feeling, guys? Any effect? You still feeling okay? Surely you would say this, because if they were in any way incapacitated, it would be a disaster.
When NASA designed the trajectory to go through the Van Allen radiation belt, it was done so the astronauts would go very, very quickly through there, so they wouldn't get a very high dosage. And they also picked a part of the Van Allen radiation belt which the levels of radiation were quite weak.
NASA claims the astronauts endured only a brief exposure, penetrating the thinnest section of the belts in 1 hour.
The Van Allen radiation belt is a zone of radiation around the Earth. It's shaped a little bit like a donut with two centres in it. It's got a very strong, nasty area around here. As you can see, that's a darker area, and that's the inner belt, and an outer belt over here, which is a little bit more benign. Now, the Apollo astronauts were sent on a trajectory which avoided the inner belt, so they were at a relatively safe part of there, and they went through fairly quickly, so they didn't hang around inside the Van Allen radiation belt for very long.
But once they passed through, they faced an even greater danger.
So here we have these clowns running around in tinfoil craft, stopping solar radiation. And I'm not talking about the light, I'm talking about the radiation from the solar storms.
There's always risk in space. For example, you can have solar storms where you can get massive doses of radiation being flung out from the sun.
These eruptions from the sun can knock out satellites and electricity grids on Earth. But they can also be detected by an early warning computer system.
If there was some form of solar storm, a big radiation discharge, that the astronauts could actually be exposed to an unacceptable hazard, which would be a real risk. So there were solar scientists actually monitoring the solar activity to make sure that they weren't about to launch into a potential problem.
Just 3 months after the Apollo 16 mission, NASA admitted that a violent solar flare hit the moon's surface, an eruption so powerful it could have killed the astronauts had they been there.
The point is that the American Apollo astronauts did not have protection against these levels of radiation. And we know that because NASA now admit, as a result of the Orion craft, which is Apollo 2.0, that the levels of radiation are such that they have to find out means to protect them before they can send humans through these levels of radiation. But they'd sent the Apollo astronauts, so what's the problem? The problem is they didn't send the Apollo astronauts.
I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth.
Those were the words of President Kennedy in 1961. There were three parts of that sentence. There was get humans to the moon, before the decade is out, and safely. And safely was only one of the three. And there were a number of occasions during the course of the Apollo program when particularly the phrase, before the decade is out, kind of took priority over safety. Sometimes they had to take some risks in order to keep to the schedule.
The astronauts could only rely on their spacecraft to survive a solar flare.
By studying the disk of the sun, you can make predictions about when these are going to likely happen and avoid those times. And even if there was a storm, if the astronauts were in the command module, you could rotate the command module so you've got a lot of the fuel, the oxygen, the water in between the astronauts and the direction the radiation's coming in. And if we're on the surface, then you could potentially go and hide behind a rock, or you could even launch off from the surface before the nasty bits of the solar storm arrive.
For conspiracy theorists, radiation is the final nail in the coffin. They believe the astronauts could never have survived a trip to the moon and back. But could the objects they returned with also be the key to unlocking secrets from the lunar surface itself and provide a definitive answer to the question, did we really land on the moon? Conspiracy theorists believe that the moon rock from the missions was just another part of NASA's carefully engineered deception.
Wernher von Braun and a few guys from NASA went down to Antarctica. What's he doing in Antarctica? Finding moon rocks.
It's quite possible that these Earth-lying rocks have been doctored to give the semblance of moon rocks.
It would be really, really tough to fake these things. It would be really hard now, and certainly 50 years ago, the idea that you would spend resources on producing some kind of secret lab rather than actually sending people to the moon to bring them back.
But how many people have actually examined the moon rock and can confirm where they came from? There's a great deal of doubt about it.
In total, the Apollo missions brought back over 382 kilograms of lunar soil and rock. These samples were distributed to laboratories all over the world. At the independent Berkeley Geochronology Center in California, geologist Paul Rene has been studying lunar rock samples throughout his career. His main interest is these tiny glass spherules from the moon's surface, created by the intense heat of a meteorite impact.
The spherules that we've been analyzing are tiny balls of glass, so they're like magma that we find on the Earth in that sense. But they've cooled very, very quickly, and so they form a essentially uniform glass sphere.
Using a laser heating system to release gases locked inside these spherules, Paul Rene looks for evidence of cosmic radiation to uncover clues about their age and place of origin.
The lunar materials that we've analyzed and that others have analyzed show evidence of having been bombarded by cosmic radiation, and which we don't see on Earth because we have an atmosphere that really shields them very effectively.
Rene has determined these spherules date back 3.9 billion years. This finding eliminates the possibility that they originated on Earth.
So the Earth, with its very dynamic environment, does not tend to preserve these glassy objects, whereas the moon, being essentially dead from a thermal point of view, does tend to preserve these things. The results that we obtained are absolutely definitively proof of a lunar origin. I can say with utmost assurance that they were derived from the moon.
But it's evidence the astronauts left behind, and not what they brought back, that may offer the clinching proof. Each successful Apollo mission set up a range of experiments, and 50 years after Apollo 11, the lunar laser range is still in use.
There were two major experiments. One was a series of corner reflectors to reflect laser beams from the Earth sent to the moon that then, because of the geometry of these corner reflectors, would send the beam back in exactly the direction that it came from.
But conspiracy theorists believe that these experiments were taking place before the Apollo missions.
You don't need retroreflectors to fire a laser. It was being done by the Massachusetts Institute of Technology in 1963. They were firing lasers at the moon. No reflectors there then. Nobody had landed then, and they were getting a signal back.
If this had already been achieved without a reflector, what was the advantage of NASA placing these on the lunar surface?
There are no lasers there. NASA only did the reflector business so they could prove they went to the moon. It was just another part of their ploy.
You send a laser pulse from the Earth with a very powerful laser pointing for a big telescope at a location on the moon, and it reflects a lot of that light back to you. So it's fairly directional, it comes straight back to you, it doesn't get scattered. And by measuring the time difference between when you send the pulse and when you get the received pulse back, you can work out the distance to the moon very precisely to literally centimeters.
The reflectors placed by the Apollo 11 crew allowed scientists to achieve greater accuracy about the Earth's position in the solar system.
Pretty much anybody in the world with a big telescope, with a powerful laser, can bounce, without getting permission from NASA, lasers off of those reflectors and measure the distance to the moon. So that proves to me that the astronauts went there and they left these laser reflectors at these different locations.
If NASA had faked this, surely the Russians would have exposed the legitimacy of this half a century ago. At the height of the space race, the Soviet Union and East Germany also had the technology to listen in on the Apollo missions. And yet conspiracy theorists ignore the eavesdropping power and silence of America's arch-enemies.
They weren't at war, but this was as close as they could get, if you like. Any form of fraud on the part of either party would have been exposed by the other party very quickly.
If the Russians said publicly it was a fake, they would need evidence. Otherwise it would just be sour, it would look like sour grapes. But they had no evidence because NASA had everything.
But even with no doubt raised by the Russians 50 years on, perhaps all great human achievements are destined to attract skepticism and controversy.
There will be landings, there will be men, there will be women on Mars soon. I hope that we don't see the same pattern of conspiracy theories surfacing, simply because it'll be one of the biggest, if not the biggest, achievement of mankind.
They got to the moon with basically 1960s technology. Now with our technology, with advanced computers, etc., it's still going to take them 25 years just to get back to the moon. Now really there's something wrong there.
When we see real conspiracy theories that become public, whistleblowers give away the secret after a few years, even though there are only a small number of people involved. Some people seem to feel that a conspiracy has kept it secret for 50 years, even though tens of thousands of people were in on the secret.
For all the effort it would take to create and hide a lie of such magnitude, it would have been far easier for NASA to build a rocket and put man on the moon.
April 1970. NASA's Apollo space program is in full swing. The last 16 months have seen 12 men fly to the moon and 4 walk on its surface. For the crew of Apollo 13, preparations continue for NASA's most ambitious mission yet. Navy captain and veteran astronaut Jim Lovell is mission commander. Lovell is one of NASA's most experienced astronauts, and Apollo 13 will be his 4th spaceflight.
Well, I was among the second group of astronauts that came into the program back in 1962. My experience before consisted of basically naval aviation, mostly in the testing field. In NASA, I was assigned to 2 Gemini missions. Frank Borman and I were assigned to the Gemini 7 mission, and then Buzz Aldrin and I completed the Gemini program with Gemini 12. After that, I went into Apollo. I was a backup, actually, to Mike Collins. Mike had a neck injury, so I replaced him on Apollo 8. I then was a backup to Neil Armstrong on Apollo 11, and from there I worked back into Apollo 13, and that's where I am now.
The early astronauts who ranked for commander status in the early Apollo missions were test pilots who were very necessary for really getting hold of these beasts, putting reins on them, and wringing out the very best that they could in performance.
2 other former experimental test pilots will fly alongside Lovell on Apollo 13. Ken Mattingly assigned as command module pilot, and Fred Hayes will fly as lunar module pilot. For both Mattingly and Hayes, Apollo 13 will be their first flight in space. But just 7 days before the launch, the mission is already facing problems.
It all sort of started just before the flight. As we are approaching the final phase of our training, a turn of events occurred, and Ken Mattingly was exposed to the measles.
Ken Mattingly was the only member of the prime crew who didn't have immunity to measles.
At that time, we had to make a big decision. It was one which was not easy for me to help decide, and when they asked me what I wanted to do.
The flight surgeon's decision was that it was too big a risk to fly Mattingly on the mission, and therefore Mattingly was pulled from the Apollo 13 flight, and Jack Swigert, the command module pilot on the backup team, was substituted.
The only apprehension that I have is that you work together as a crew. We did find that we did almost everything the same. And once this was determined, I had no apprehension at all. I felt that it was my job to get Jim and Fred there rested. I felt I could do that. I felt I could accomplish the majority of the orbital science objectives of the flight. I felt that we had a good mission and we could do it all.
Jack Swigert will now fly as command module pilot alongside Jim Lovell and Fred Hayes. Apollo 13 will be his first flight in space.
The main mission objective of Apollo 13 is basically the scientific exploration of the moon. We hope to find out a lot about the origin of the moon, and from that, the origin of our own planet, the Earth. We have, of course, a secondary objective in continuing the development and testing of the space systems itself for, of course, in future flights to other places.
Apollo 13 really went to take a step further than the previous two Apollos that had been on the moon. They had landed in areas called mare, these sort of flat plains, which occupy quite a bit of the moon's surface. And they contain no digging implements, really, so you only looked at the rocks that were right on the surface. And there's a lot of interest in really what's happening down below the surface of those mare. So Apollo 13's aim was to go to an impact crater where some huge collision had happened with an asteroid. That impact had thrown material out, and it sort of dug it up from lower regions of the crust. And Apollo 13 was targeted to an area called Fra Mauro, where there were uplands that had some of this material, this impact debris exposed. And that was really their main aim, to try and get to rocks that were characteristic of a different age of the moon compared to Apollo 12.
The particular objective of 13, of course, is a highland landing. We'll use the lunar module to land in a mountainous or hilly terrain called Fra Mauro, to explore Fra Mauro on foot, to look and find out exactly how it was formed, and also to deploy an experimental package called ALSEP.
It was a mission where the crew were definitely very interested in the science. The previous flights had been mainly engineering flights, Apollo 11 and Apollo 12, although a lot of science was done on both of them. We decided that we were going to have a heat flow experiment, which was going to measure any potential heat coming out of the moon, and that needed a drill, a Black & Decker 12-volt drill, specially developed to drill these 3-meter holes, 1 inch in diameter, on the lunar surface. It was a more sophisticated piece of equipment than flew on Apollo 12. Having the drill was a difficult thing to work on. They had to drill the 2 holes, they had to put probes down in them and have all this connected up to the central station. It was the most complex experiment that we had up to that time. But 13's motto was from the moon knowledge, and the crew were really enthused with the science they were going to be doing and to do the best they could with our equipment. And we had a very good working relationship with them.
But the American public does not share NASA's enthusiasm for the next Apollo mission. With the Vietnam War raging on and US ground troops having faced fierce combat for over 5 years, public interest in the moon is fading fast. People believe Apollo 13 will just be another routine flight.
Public interest in the Apollo program reached a height in July 1969 when Neil Armstrong and Buzz Aldrin landed on the moon, but it rapidly decayed after that. There was some press coverage of Apollo 12, but by the time Apollo 13 flew, very little interest was shown. In fact, it was said that the TV companies, the broadcasters, were inundated with complaints from members of the public that their favorite programs were going to be bumped off schedule to cover Apollo 13.
It's interesting how quickly the public, and I guess we're talking mainly the American public, but worldwide as well, how quickly they sort of got a bit bored with it all, because it all seemed to go just like clockwork, didn't it? And people had got completely fed up with seeing the crew weightless and just poking at bits of equipment that nobody could understand.
I think one of the problems there was that NASA was not emphasising enough the science that was going on and the knowledge that was coming back. So interest was waning until the accident. And some people thought the accident was a stunt, just to get interest back again, but of course it wasn't.
For the eyes of the world now look into space, to the moon, and to the planets beyond. And we have vowed that we shall not see it governed by a hostile flag of conquest, but by a banner of freedom and peace. We have vowed that we shall not see space filled with weapons of mass destruction, but with instruments of knowledge and understanding.
This is Apollo Saturn Launch Control. Now, as we move into the final phase of the countdown, we're receiving go, no-go checks from various elements of the launch team. The spacecraft test conductor gave the test supervisor a spacecraft ready. And the director of launch operations has given Apollo 13 a go for launch. T-minus 1 minute and counting. First stage, second stage, third stage going to internal power. T-minus 25 seconds and counting, and Apollo 13 is go. "17, guidance release, 15, 14, 13, 12, 11, 10, 9, 8. Ignition sequence has started. 6, 5, 4, 3, 2, 1. We have liftoff at 2:13. The Saturn V building up to 7.6 million pounds of thrust, and it has cleared the tower.
Houston, go at 30 seconds. Roll complete and we're pitching. Roger that.
You feel a Saturn V launch. It actually shakes you. You really are willing it to go.
Altitude 1.2 miles, velocity 1,500 feet per second. Stand by for mode 1, Charlie.
It's like millions of thunderclaps going off. All the simulations are done, all the rehearsing is done. Now it's time to get on with the job.
And 13, your go for staging. Go for staging, we're idiot, manual.
But 5.5 minutes into the mission, the crew feels unfamiliar vibrations during the second stage boost.
Inboard. We confirm inboard out. Jim Lovell reports the inboard engine has shut down a bit early.
Suddenly, the central inboard engine shuts down 2 minutes ahead of schedule.
The early shutdown worried the crew, and they reported to the control center, something's happened, can you give us a reading on it?
Houston, what's the story on engine 5? Jim, Houston, we don't have a story on why the inboard out was early, but the other engines are go and you're go. Roger.
They were quickly reassured the other 4 engines were completely capable of getting them to orbit, so they knew within a few seconds of it happening that it wasn't going to affect the mission.
To Mission Control, the cause of the engine cutoff is a mystery. but it's a mystery that may have saved the entire mission.
During the ascent through the atmosphere, vibrations built up in the vehicle. In fact, these vibrations, known as pogo because of the way that the rocket vibrates along its axis like a pogo stick. These have been known since the beginning of flight of liquid-fueled rockets.
Pogo was a recurrent problem with the Saturn V's large engines and could create such variation in their thrust that the vibrations could literally shake the vehicle apart. On Apollo 13, there were 3 instances of pogo vibration. The first 2 were similar to pogo that had been seen previously, but the third almost brought the mission to an end in a catastrophic way. The central engine of the second stage was vibrating vertically 16 times a second and severely flexing the Saturn V's framework.
So they had sensors in to detect when this was happening, and one of those sensors shut down the center of the cluster of 5 engines.
But had the vehicle gone through another cycle of growth of this pogo, it would have taken the vehicle outside of the structural limits, and that would have been catastrophic. And it's the Apollo 13 flight that galvanized the flight engineers to actually go back and revisit pogo, because it was obvious that the vehicle had been taken very close to failure, and pogo suppression measures were put in place.
13 Houston, trajectory's good, thrust is good. Roger. And we don't have too much of a handle on why the inboard cut off early, except that it apparently was an engine problem, but we're certain that you'll be able to make TLI based on what we're looking at now. Roger, nothing like an interesting launch. That's right.
After the early engine cutoff, the flight continues as scheduled for the first 2 days. Apollo 13 is on course for the moon, looking to be the smoothest mission of the program so far.
Okay, you're on candid camera.
We did notice one thing, Vance.
Right.
Can't call me here up here.
Well, I guess you have to give up something.
And I thought we'd get a picture of Jack, just so that all the girls know that he's still here.
Yeah, we appreciate that. There he is, Big Jack.
Apollo 13 presently at 177,861 nautical miles away.
"55 hours and 46 minutes into the mission, the crew finish a television broadcast showing how comfortably they live and work in zero gravity.
And now, for the benefit of the television viewers, Fred's engaged in his favorite pastime, I found out on this flight so far.
He's not in the food locker, is he?
That's his second favorite pastime. He's rigging his hammock for sleep on the lunar surface now to try it out to see what it's going to be like.
Roger, sleeping and then eating.
Yeah, it's kind of difficult here, Jack, getting into a hammock in 0G. I'm not sure if I keep floating away from it or it keeps moving away from me. We might give you a quick shot of our entertainment on board the spacecraft, which has been keeping us company for some time. This little tape recorder has been a big benefit to us in passing some of the time away on our transit out to the moon. And it's rather odd to see it floating like this in Odyssey while it's playing the themes of 2001.
Okay, Jim, it's been a real good TV show. We think we ought to conclude it from here now. What do you think?
Roger, sounds good, and this is the crew of Apollo 13. Wish everybody there a nice evening, and we're just about ready to close out our inspection of Aquarius and get back for a pleasant evening at Odyssey. Apollo 13, Houston, we've got one more item for you when you get a chance. We'd like it to stir up your cryo tanks. Okay. Stand by.
7 minutes after finishing the broadcast, Mission Control instructs Jack Swigert to turn on the fans inside the spacecraft's 2 liquid oxygen tanks, a routine procedure to stir the tank's contents. But as the fan inside the number 2 tank switches on, damaged wiring creates a spark.
The flight up until
about 56 hours was, I guess what you'd call entirely nominal. We had followed the flight plan. We were ahead of the game.
Fueled by the oxygen, a fire spreads inside the tank. The rapid pressure buildup ruptures the oxygen tank.
Fred was still in the lunar module. Jack was back in the command module on the left-hand seat. And I was halfway in between in the lower equipment bay, wrestling with TV wires and a camera.
High-pressure gas floods the fuel cell bay in the service module, blowing out a 13-foot panel of the spacecraft.
When all three of us heard a rather large bang, just one bang.
Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Stand by, they got a problem. We got more than a problem.
Okay, listen, you guys. Fuel cells 1 and 3 are offline.
Right. That's what we're reading.
Flight engineers at Mission Control immediately respond to their instrumentation, which is indicating a major systems malfunction in the command service module.
Well, we're showing low N2 pressure on fuel cell 1. We're showing low O2 pressure on fuel cell 3.
That can't be.
Yeah, we might have lost fuel cell 1. And it looks like fuel cell 3 is gone. I can't believe that right off the bat.
Two of the spacecraft's 3 fuel cells appear to have been lost. These fuel cells are the prime source of electrical power in the command service module.
With the massive buildup of pressure from the cracked and split tank, there was a tremendous release of energy that not only blew the panel off, but shoved up the shelf on which the 3 fuel cells were sitting.
The shock closed a number of valves, and the fuel cells were running only on the oxygen that was in the lines from the valves down to the fuel cells. So they only had a few minutes of power left.
Fearing the spacecraft's hull may be damaged, Swigert rapidly attempts to seal the tunnel hatch between the command module and the lunar module.
The source of the bang not immediately determinable, and I was afraid that we might be vulnerable to losing pressure, so I proceeded to get the hatch in.
We're starting to button up the tunnel again.
5 times, Swigert and Lovell try to lock the hatch in place, but the crew decides to stow the reluctant hatch and turn their attention to a new problem.
The oxygen pressure had gone in cryo tank 2, and the pressure in tank number 1 was rather slowly but steadily decreasing. It was obvious it wasn't holding its own.
We lost O2 tank 2 pressure.
We got to get a pressure readout on that thing.
O2 quantity number 2 is 0.
My concern was increasing all the time. It went from, I wonder what this is going to do to the landing, to I wonder if we can get back home again.
Looking out of the command module window, Jim Lovell sees gas venting from the service module into space.
And it looks to me that we are venting something out into space. It's a gas of some sort.
Roger, we copy your venting.
Not only is the number 2 tank completely empty, but the remaining oxygen stores in the number 1 tank are now leaking into the vacuum of space.
And when I looked up and saw both oxygen pressures, one absolutely 0 and the other one going down, it dawned on me, and I'm sure Jack and Fred about the same time, that we were indeed in serious trouble.
Although the command service module can operate on just 1 fuel cell, it requires an oxygen supply to generate power.
The force of that massive expansion of gas caused leakage to begin in the number 1 tank. There was insufficient pressure coming from that tank to keep the 3rd remaining fuel cell alive. Within 2 hours, the 3rd fuel cell had to be shut down.
It was quite apparent to me that it was just a question of time that the command module was going to be dead, that we were going to lose that fuel cell also.
That's the only means of electrical power for everything needed to get the crew back to Earth alive.
200,000 miles from Earth, astronauts Lovell, Hayes and Swigert are now flying towards the moon in a dying spacecraft. NASA must devise a plan to bring their men home before the remaining fuel cell fails completely.
Apollo Control, Houston, continuing to closely watching oxygen quantities, and if necessary, the 13 crew can use oxygen from the lunar module.
At the beginning of the Apollo program, NASA needed to develop a system that would successfully fly astronauts to the moon and back, and the decisions that were made will now directly influence Apollo 13's chances of survival.
At the very start of the program, when it was just drawings on bits of paper, there were a number of options, and various parts of NASA preferred various options. One option was to build a huge rocket, much bigger than Saturn V. It was called the Nova, and just send them straight to the moon, land the rocket on the moon, and then it was so big it had got fuel to come back. This was favoured, I think, by von Braun, actually. Then there was another scheme which had you go into Earth orbit, and then you separate out into various units, and some of them travel to the moon, some of them don't.
The system NASA committed to, known as Lunar Orbit Rendezvous, uses two separate specialized spacecraft, the Command Service Module and the Lunar Module, known as the LEM. The Command Service Module consists of two sections: the pressurized Command Module capsule that housed a crew of 3 astronauts and the equipment needed to fly to the moon and back, as well as survive re-entry and splashdown, and the larger Service Module that provided propulsion, electrical power and storage for the Command Module consumables, such as oxygen and water. The Lunar Module was designed to fly 2 astronauts down to the moon's surface, while the 3rd astronaut stayed in lunar orbit in the Command Service Module. Therefore, the Lunar Module had its own independent life support and power systems necessary to support the 2 men while they explored the moon. Within 3 hours of the tank rupture, all oxygen stores in the Service Module will be lost, along with all supplies of water, electricity and propulsion, and the Command Module will be unable to sustain life. But the benefits of the Lunar Orbit Rendezvous system are about to offer Apollo 13 a chance of survival.
Flight Econ.
Go ahead, Econ.
The pressure in O2 Tank 1 is all the way down to 297. We're going to hit 100 psi in an hour and 54 minutes. That's the end right there.
We're starting to think about LEM Lifeboat.
Yeah, that's what we're thinking about too.
We figure we've got about 15 minutes worth of power left in the command module, so we want you to start getting over in the LEM and getting some power on that.
It was apparent, and the ground told us so, and they were right on the ball all the time, that the only way to survive the situation was to transfer to the lunar module, and we started going through procedures to get power on and to align the platform.
With its independent life support, power and guidance systems, the Lunar Module can act as a lifeboat and keep the crew alive.
The Lunar Module could act as a lifeboat because it's an independent spacecraft and it was designed to go down to the lunar surface and come back, which meant it had a lot of capability, propulsion capability, life support and guidance. They were able to use all those functions as a backup to the failed systems in the Command Module.
The Lunar Module was the only vehicle available to get them out of a very tricky situation. Without use of the Lunar Module, the mission was lost. I mean, everything was lost.
Contingency plans to use the Lunar Module as a lifeboat had been drawn up by NASA earlier in the program, but now these plans and the spacecraft itself will be tested to the limit.
Gee, I think back in Apollo 9 we first started looking at the LEM as more or less a lifeboat, and fortunately, although the exact procedures do not tailor the exact case we've got, we had looked at the utilization of the LEM for an awfully long time, so we knew what the limitations were. We developed workaround procedures wherever it was possible. I think the LEM spacecraft's in excellent shape, and I think it's fully capable of getting the crew back. I think, as we have found before, every time we've put the LEM spacecraft to a test, it's always done much more than it was guaranteed to do, and I think this is a good case in point.
So a lot of thought had been given to the possibilities of rescuing the crew. Well, we didn't end up with a rescue capability. We didn't end up with a system that had duplicates. But we did have a system that could be turned on its end and used in a completely different way.
1 hour after the oxygen tank rupture, the dying systems in the Command Module have started draining power from the re-entry batteries.
On Apollo, electricity was generated from fuel cells which use oxygen and hydrogen to react. And so the loss of oxygen in the Service Module meant that the spacecraft could no longer generate power, and the only power remaining was in batteries used for re-entry.
During a normal mission, the Command Module capsule was separated from the Service Module just prior to re-entering the Earth's atmosphere. But this separation severed its power supply from the onboard fuel cells in the service module.
So you have to have batteries in the command module to keep you going, and the re-entry batteries do that job. And without them, you can't operate the command module through re-entry.
We have 3 re-entry batteries in the command module, and we have no way of recharging these things now with the fuel cells gone, so we don't want to waste any of this valuable electrical power by running unnecessary equipment in the command module.
The command module must not run on the re-entry batteries any longer than necessary. Without these batteries, the crew will not survive the hazardous descent through the Earth's atmosphere. To minimize power consumption, Mission Control initiates emergency power down procedures.
We've really got to get that battery off the line.
Ecom, I think we ought to start powering down.
Yeah. Emergency 1-5, power down.
Okay, 13, this is Houston. We'd like you to go to your checklist, emergency pages 1-5. Power down until you get an amperage of 10 amps, less than what you got now.
All non-essential systems in the command module are shut down except for the guidance computer, which holds the critical parameters needed to direct the spacecraft home. The crew must now race to power up the lunar module and transfer these guidance parameters to its onboard computer before they lose power in the command module.
It normally took 3 to 5 hours to power up a lunar module. They had to do it in 90 minutes.
They were really rushing to close down the command module and bring the lunar module up from cold.
They had to use modified lunar module power-up procedures, and these were developed very quickly between the crew and the ground, and they had to shortcut to get the lunar module up to keep them going.
We knew that the command module was going to lose it pretty soon because we're going to lose power. The first milestone was to get alignment on the LEM platform. Alignments are important because without knowing exactly which way the attitude of a spacecraft is in space, there's no way to tell how to burn or how to use the engines of that spacecraft to get the proper trajectory to come home. So we had to have an alignment on board the spacecraft.
A very important phase was when they were leaving the command module. The LEM attitude system didn't know where it was pointing.
Alignment of the guidance reference was normally done using stars. The problem after the incident was that there was debris floating around the spacecraft.
There was a whole bunch of particles like fireflies in a night sky. Jim Lovell was totally unable to get any sightings.
Fred and I went into the lunar module. Fred got the power on. We started to align the platform.
They needed to transfer guidance system knowledge of where things were pointing from the command module to the lunar module.
We used a procedure that was in the activation checklist. Jack gave us the angles.
And so they had to manually actually read the coordinates out and shout them into the LEM, and they were punched into the computer there.
I was so concerned about being sure that this arithmetic was correct that I had actually called down to the ground, let them do the math, came back in and put it in. But we did get a platform alignment, and that was our first milestone.
Once the guidance parameters are logged in their lunar module's navigation system, the command module is powered down to preserve precious re-entry batteries. With the lunar module acting as a lifeboat, NASA has stabilized the situation, and the crew have been bought some time.
My own personal involvement was that I was in the mission evaluation room. The mood in Mission Control was immediately one of disbelief. There was that sense that, okay, we've got a problem, it's the data. We see dropouts often. You see failed sensors giving erratic and spurious information. And then you begin to realize that there are a lot of things, and this is minutes, this is not hours. In minutes, you begin to realize there's a cascade of events which are tumbling, which means that they can only have one root cause. And the initial reaction was stabilization, to get the whole mission stable so that we could at least buy a bit of time.
If the situation remains stable as it is at the moment, there's no question but what we have the thing under control and we can return the crew safely to the Earth. Now, we're going to have to make some compromises in procedures as how you do that. But if everything remains as is, we can get them back successfully.
But we were running out of time to get the spacecraft back on course. So rapidly there had to be, okay, there's no time for stroking our chins, wondering what's going on. Now's not the time to try and diagnose what the fault was. That will come later. Let's deal with the here and now, go forward, straight on.
We were trying to figure out what to do rather than to play out the old data.
And that's what we'll be doing till we get them back on the water, is concentrating on everything that is their lives are dependent upon at the moment rather than worrying about the accident, because there's nothing we can do about that now. The service module is no longer useful in most cases because the oxygen is depleted.
Essentially, assimilate as much data as possible, assign people to study those particular problem areas on how we keep the crew alive and how we keep our options open.
I was involved with the ALSOP experiment. I was a test engineer working at the Cape. We were called in the middle of the night telling us that it had happened. We went in and we had a discussion about whether we could use our nuclear power plant, which was on our experiments, on the ALSOP experiments, to give them extra power. They'd have to go outside, which would mean using a lot of oxygen because you'd have to depressurize and repressurize again. They'd be working with a hot 1500 degrees fuel capsule, maneuvering that in zero G, getting it into the generator, and then finding a way of connecting that to the power system. And it was decided it was just too dangerous. They just would not succeed in doing it.
I worked as a support contractor to the Guidance and Control Division during Apollo. My impression during the early time of the mission was great concern for understanding what had happened and the best way to get out of the situation. And although there was a lot of tension among all the people, nobody really lost it. They somehow kept going and encouraged the crew. The crew, more than anybody, knew how serious the situation was. One gets the impression of a sort of calm, searching for answers, but nobody really getting upset. And I think if anybody had really got upset, that probably would have been very serious.
NASA must now focus on the best strategy for returning Apollo 13 home. The free return trajectory was a flight path to the Moon designed by NASA earlier in the Apollo space program. Established by the Saturn V rocket, this trajectory would send the command service and lunar modules towards the Moon and use the gravity of the Moon to slingshot the spacecraft back to Earth without the need for further propulsion. The advantage of this trajectory is that in the event of a systems failure on board the spacecraft, the crew would still return safely home. However, as the Apollo space program progressed, the free return trajectory would restrict NASA from visiting more scientifically interesting landing sites. Therefore, a hybrid trajectory was flown from Apollo 12 onwards, where the spacecraft would maneuver away from the free return onto a specific translunar trajectory to reach their landing site. Prior to the oxygen tank failure, Apollo 13 had departed from the free return trajectory. But with its limited power and consumables, it is now vital that Apollo 13 maneuvers back onto the free return trajectory to make use of the Moon's gravity and slingshot back towards the Earth. Failure to get back on the free return will see the crew locked in lunar orbit, adding greater strain on the already limited consumables. But with the condition of the service module and its large propulsion engine uncertain, NASA is left with no option but to use the lunar module's smaller descent engine to fire the spacecraft back onto the free return trajectory.
We're going to make a free return maneuver of 16 feet per second at 37 minutes from now. That's a 16 foot per second dip burn in 37 minutes. Roger.
Many years before the first landing, one of the senior managers must have had a bad dream or something, because he said, what if that main engine that we need to get us back to Earth fails? It drops us into Moon orbit, but we've no means of reigniting it. I want to know, he said, if the lunar module's propulsion system and its onboard consumables can be worked in such a way that it can get the crew out of moon orbit and on their way back to Earth. And those tests were done. And Grumman, the manufacturer of the lunar module, conducted tests to see how you'd steer the attitude of the two spacecraft from the other end, how you'd use the descent engine, normally used for going down to the surface of the moon, to boost you back out of moon orbit and back to Earth.
I had never tried that before. I really don't know who had, and it's a very difficult task. And we spent a lot of our first part of our emergency or survival time just learning how to control the spacecraft in this mode.
Almost every facet of the procedures that were used to get the crew back had been simulated in one way or another, but the really, really crucial thing which everybody feared was that nobody had put those all together in a string of events. It was always thought, well, this might happen, that might happen, one or the other, but never all in a row as they did on 13.
With time for the course correction running out, Mission Control and the crew work quickly to configure the lunar module for the free return burn.
Okay, here we go. The mid-course correction for free return. And I have your LEM GDA angles. Pitch, 5.86. Roll, 6.75. Your dip throttling, 5 seconds at 10%. Burn the rest at 40%. GDA angles, pitch, 5.86. Roll, 6.75. Dip throttle, 5 seconds at 10%. Burn the rest at 40%. Roger. Okay, Jack, we have a mid-course for free return. Game master on 1 minute.
Roger, Aquarius, you go for the burn.
%.
Okay, Aquarius, you're looking good.
Okay, you're looking at 1685 now, Jack.
That's affirmative, no trim required.
Roger. Auto shutdown. Okay, Houston, burn complete.
Roger.
With the successful firing of the lunar module's descent engine, Apollo 13 is once again on the free return trajectory back to Earth. But with only a 45-hour lifespan intended for a 2-man crew, the lunar module must now be configured to keep 3 men alive for over 90 hours.
Our feelings varied during the emergency. There were moments when I didn't know how much consumables we had, whether we could make it back or not, but in a situation like that, there's only one thing you can do. You just keep going, and you just keep thinking up where you can get more consumables. And so that's exactly what we did.
Well, the lunar module is not a big space. It's about the size of 1.5 telephone booths inside. To enable it to support 3 men for 3.5 days, the whole way in which it was operated had to change.
A big problem that faced them initially was what we call the consumables, so the oxygen, the electrical power, as it turns out the water, and then crucially towards the end the carbon dioxide. They had rather a small amount of electrical power in the command module, but they had oodles of it in the LEM, so they weren't really worried about lasting a couple of days in the LEM. Interestingly, they had a fair amount of oxygen to breathe in the LEM as well, and it's not difficult to understand why that was, because of course the LEM was planned to go down onto the lunar surface and open the door and let all the oxygen out, so they got plenty of oxygen to breathe in the LEM. Electrical power for the LEM was available, but the real crucial point was that they needed water to cool the electrical equipment. You can imagine all of these high-power things all jammed into this tiny space, so big problem with getting the heat out.
You can't cool electronics in space because vacuum doesn't conduct heat, so you don't get convection. So you need to cool them in an active way, so you run cooling water on cold plates. You put the electronics on cold plates. That's what we did on Space Lab. And you can keep things cool, stop them overheating and failing.
Mission Control estimates that the spacecraft will run out of water 5 hours before Earth re-entry, unless the crew restrict water usage as much as possible. All non-essential systems in the lunar module are powered down, and the crew reduce their water intake to 1/5 of normal consumption, but suffer serious dehydration.
They powered down the lunar module as much as they could. I think it was only drawing about 20% of the power that it normally would, to reduce the cooling requirements. And I think they had about 4.5 or 5 hours of cooling water left by the time they got back to close to the Earth, when they detached from the lunar module. But they had about 120 hours of oxygen, because there was a lot of oxygen on the lunar module. They were not short of oxygen at all.
One of the great triumphs of the Apollo 13 rescue was the way in which the team managed to eke out those consumables and go from a situation where the consumables were predicted to be expended before the spacecraft got back, to a point where there was actually a little bit of slack in the consumable store by the time the vehicle returned to Earth.
But despite all of NASA's achievements in stabilizing the situation, one twist of fate remains undeniable. Had the oxygen tank ruptured at a different time during the mission, the astronauts would have been stranded in space with no hope of recovery.
There was a lot of fortunate incidents in 13 that would make it a completely unlucky flight. At the time it happened, I thought was the worst possible time. Obviously, it was not the worst possible time for this particular incident to happen.
The oxygen tank failure occurred at a distance of about 200,000 miles from the Earth as the spacecraft was approaching the Moon. That is a quite fortuitous place for this to happen. Had the oxygen tank failure happened several hours before the point when it actually did, then the situation would have been very, very difficult. It's very likely that it would not have been possible to stretch the consumables out far enough so that the astronauts still had water and electrical power in time for re-entry. And without power for re-entry, the mission was doomed.
When you lose 2 fuel cells and an oxygen tank and the oxygen runs out of the other and all that, that's something very significant. It'd be very difficult to design against that. We're fortunate that we're on the way to the Moon with the LEM on board, or LEM attached.
If the explosion had happened before they had connected the lunar module round to the command module, then the astronauts couldn't have got into it, so there would have been no lifeboat.
Any time that you still have the lunar module in the condition that we have it in this case, where we've not used any of its consumables, then we're in a very good situation. We've always called the LEM a good lifeboat under those circumstances. If at any time in the mission, however, the LEM had separated, then it would be a fatal situation.
Had the event happened later, after the lunar module had separated from the command module, after the point where the 2 astronauts bound for the lunar surface had actually detached and were on their way down, or even on the surface, then the situation would have been very serious because of the fact that the command service module would have been left without any power, so communications with the astronauts on the surface would have been not impossible.
You'd have had a dreadful, dreadful situation where the guy going around the Moon was lost, and the 2 guys on the Moon for a while were okay, but then there was no way back for them. So if you're looking for good luck in the Apollo 13 story, it was that it happened when they could rescue them. There were a lot of opportunities before that and after that. If it had happened then, they couldn't have rescued them. So I don't think we should ever believe that rescue was inevitable here. And a lot of the NASA engineers, although publicly they were saying, well, you know, this is fine, their estimate of the chances were below 50-50, and some a lot less than that.
If you're going to have a catastrophic failure of an oxygen tank on a flight to the Moon, then somewhere around about 200,000 miles from the Earth outbound is possibly the best place to have it.
Apollo 13 now 421 nautical miles above the Moon. Just a little over 1 minute now from time of loss of signal with the spacecraft standing by, continuing to monitor. This is Apollo Control, Houston.
We're still something like 70 to 80 hours away from the Earth. I would only guess that the crew feels that the situation is under control, but they were in a serious condition and they knew they had a job to do. If the situation remains stable as it is at the moment, we have the thing under control and we can return the crew safely to the Earth.
With the spacecraft back on course, the consumables stable, and the astronauts surviving in the lunar module, NASA has successfully averted the immediate danger. But with Earth still 250,000 miles away, the return flight is about to present the crew with a whole new series of life-threatening situations.
This is Apollo Control, Houston. We've had loss of signal with Apollo 13 as it passes above the backside of the moon. We're at 77 hours, 9 minutes, and now to the flight of Apollo 13. Apollo Control, Houston, we're coming up now on 1 minute from time of reacquiring Apollo 13. Standing by now for acquisition.
Aquarius, Houston, over. Aquarius, Houston, over. Apollo 13, Houston. Go ahead, Houston. Hey, you're loud and clear now. Roger.
With the lunar module acting as a lifeboat and the spacecraft back on the free return trajectory, Apollo 13 is on course to splash down in the Indian Ocean in 4 days' time. But with no recovery forces deployed in the Indian Ocean, the crew would be left floating in the command module waiting for rescue. Mission Control must reduce the flight time to have splashdown in the Pacific Ocean, where naval recovery forces are already in waiting.
Our first milestone was to get us back on free return. The second one was to get us home early. The flight time back home was 155 hours if we had done nothing else. But the ground had decided to burn at about 2 hours past the moon, at about 79 hours, a maneuver to shorten the time to get home again.
Not only will a shorter flight time put less strain on the consumables, but it will also ensure the capsule re-enters the Earth's atmosphere above the Pacific Ocean. The team at Mission Control have 2 burn options. Both will require the use of the lunar module's descent engine. The first will speed up the flight by 36 hours. Although the fastest of the 2 options, this burn will require jettisoning the service module, something NASA is reluctant to do.
That would expose the heat shield of the command module to very high and very low temperatures, and they were very concerned about cracking that. I mean, that heat shield was absolutely the lifeline. You couldn't re-enter the Earth's atmosphere if that wasn't in a good condition.
Well, the main heat shield, of course, was not designed to operate in free space for extended periods of time. It's designed for re-entering the Earth. And there was some concern if you jettisoned the service module that you'd cold soak that heat shield and get problems, so for that reason they preferred to keep the service module on.
Nobody knew if the command module could survive that thermal condition, super cold temperatures of space, coming back all the way without the service module attached.
And in addition, the burn will require all remaining fuel for the engine, posing yet another problem.
Further corrections to the spacecraft trajectory that may be necessary as the spacecraft approached Earth would no longer be possible.
With this in mind, NASA chooses the safer second option, a shorter 4-minute burn that will return the crew only 12 hours sooner, but will preserve fuel for later course corrections.
Given the success that the mission operations team were having in stretching out the amount of time that the consumables would last, there was no necessity to go for these very extreme options, and they could afford, therefore, to take the lower energy approach, leave some fuel in reserve, keep the heat shield safe, and come back at about launch plus 142 hours.
It was mainly a question of what is the safest way to do this. And all the decisions that were made turned out to be exactly right, because they came back almost the slowest routes you could from the moon, because they wanted to retain the possibility of making some small corrections between the moon and getting back to the Earth, so that they came in just the right height in the atmosphere. And as they approached the Earth, actually, they started drifting away, and they were quite anxious about that. So having preserved some fuel in the LEM motor for doing these corrections was exactly the right decision, because they actually needed to make those corrections on their way to Earth. It would have been horrifying if they'd, saved the astronauts only to see them zoom past the Earth, by a few miles, or crunch into the atmosphere and get burnt up, both of which were possibilities.
The precision of this burn is so critical that the flight dynamics team at Mission Control insist that the lunar module's guidance computer be used to control the spacecraft. But as this system drains a lot of power, it will have to be permanently shut down once the burn is complete. From then on, the astronauts will be flying manually.
The descent propulsion system burn duration 4 minutes 24 seconds. Flight Director Gene Kranz now going around the room for a go, no-go status from each member of his team.
Aquarius, Houston, over.
Go ahead, Houston.
Jim, you are go for the burn. Go for the burn.
Roger, understand. Go for the burn.
Less than 30 seconds away from scheduled time of ignition on our Paracynthian plus 2-hour burn for the Apollo 13. The engine is armed, standing by.
We're burning 40%.
Aquarius, Houston, you're looking good.
Roger.
Go with 2 minutes.
2 minutes, Roger.
Go with 3 minutes. 10 seconds to go.
Shut down.
Roger, shut down. I say that was a good burn.
Roger. So now we want to power down as soon as possible.
Commander Jim Lovell reporting shutdown. The engine is off. Apollo 13 now 5,426 nautical miles out from the moon. We're at 79 hours, 32 minutes into the flight.
Almost exactly 24 hours after the oxygen tank rupture, the crew complete the burn. Apollo 13 will now arrive back at Earth for a splashdown in the Pacific. But in order to preserve consumables, every system in the lunar module is once again powered down, except for the guidance, communications, and water cooling systems.
The ground was very much concerned with power, and we were too. And we decided to go into a power down mode. We turned off just about everything.
I guess everybody, myself included, got a little bit fooled about how low the LEM actually could get down to, and after completing this power down, it settled down on consuming about 11 amps an hour.
The lunar module, one of the most sophisticated machines ever built, is now running on less power than a household vacuum cleaner.
This is Apollo Control at 82 hours, 30 minutes. The lunar module has been powered down on board the spacecraft. All 3 crewmen are scheduled to be eating at this time.
In a strange way, the uniqueness of Apollo 13 came to our aid again, because this was the first mission to carry actually a level of wet pack food. So being unable to use drinking water because water was so scarce, they could actually suck moisture out of the wet pack foods to get water and electrolytes, which the body desperately needs in order to maintain the mental faculties. And mental faculties were needed pretty sharp for the crew under those appalling conditions.
With Apollo 13 speeding back towards the Earth, the crew can at last afford to catch up on some much-needed sleep.
Of course, in the early periods of this particular flight, we didn't want to sleep too much. We were sort of worried of what was going to go on. But I went into the command module one time to go to sleep, and Jack was on top of the couch and said, "Jack, put up all the window shades. Let's get the place nice and dark. We'll just relax and have it nice and dark in here. We can really get some sleep." And I woke up a couple hours later and I was freezing. As normally happens, putting up window shades in space cuts out the sunlight and normally cools down the spacecraft, but in most flights, the heat from the systems will quickly rewarm it, and as soon as we get the window shades up, you'll be in normal position again. But We got the window shades off after that, and the spacecraft never did warm up again. Command module just slowly kept going down in temperature until I think just prior to reentry, down to about 38 degrees.
With no power for the electric heating, temperatures inside the spacecraft drop to almost freezing point.
How does it feel, Jack?
I tell you, it gets cold. I don't know whether we'll be able to sleep tonight. It must be about 35 or 40 degrees. And they both came down here rubbing their hands, shivering. It's pretty cool upstairs.
Right, that's what I was worried about.
The command module, which was dead, completely switched off, completely lifeless, was cold. There was ice forming on the inside of the windows. The crew were beginning to suffer because of that environment.
We became concerned about keeping warm, and Fred and I broke out our lunar boots, which we had stowed away in the lunar module, and Jack looked at his wet feet a couple times. But he had an extra set of underwear, so he put that on.
They were so cold, they were not even able to sleep properly. And in restricting their water intake, I think Fred Hayes had a urinary problem as a consequence, and he was in pain for quite a lot of time on the way back.
It was sort of a chilling coldness. The walls were perspiring, the windows were completely wet, and it wasn't too healthy. I recall that we went in there to get some hot dogs one day, and it was like reaching into the freezer for the food.
It was a dire state. It was a real emergency situation.
The dropping temperatures not only pose a threat to the astronauts, but to vital equipment on board the spacecraft, which can be damaged by the extreme cold.
In normal flight, the command service module would maintain reasonably steady temperatures. So you design things generally to work about 20 degrees centigrade, you know, normal temperature. And you don't want things going too far away from that.
With the crew and the success of the mission dependent on this precision equipment, it is essential that Mission Control keep the spacecraft within the acceptable thermal conditions.
The people here in Mission Control Center are looking at ways of setting up passive thermal control for thermal balance for the spacecraft during the remainder of the coasting flight.
As well as facing the freezing temperatures of deep space, one side of the spacecraft is constantly baked by the extreme heat of the sun.
In Earth orbit, of course, low Earth orbit at least, half the time you're in sunlight, half the time you're in darkness. On the way to the moon, the sun's there all the time. So you don't want one side of the spacecraft getting hot and the other side getting very cold.
Mission Control instructs the crew to initiate passive thermal control, a maneuver that slowly rotates the spacecraft to evenly distribute the sun's intense heat.
Okay, Jim, in order to maintain even heating, we just have to yaw the whole machine about 90 degrees.
Okay, we have to yaw the machine in increments of 90 degrees.
That's affirmed.
So they use passive thermal control barbecue mode, which is rotating the thing about three rotations an hour to stabilize the temperature. And it also sort of controls the attitude of the thing, a bit like a rifle bullet, so it doesn't drift off too much.
This passive thermal control procedure had been used on other Apollo missions to ensure the spacecraft was kept at an optimum operating temperature. But for Apollo 13, the maneuver has the added bonus of warming the crew in the near-freezing lunar module.
They modified the angle of the spacecraft so that the sun would warm up. They warmed them up through the windows, basically.
Mission Control and the crew have been successful in establishing passive thermal control, but there is little time for celebration. Ground teams must now turn their attention to a new problem looming on board the spacecraft.
When you breathe oxygen, you exhale carbon dioxide. And that carbon dioxide, if you don't do anything about it, builds up in the sealed environment of the space capsule and becomes a poison. And so, left unchecked, the carbon dioxide concentration goes up, The astronauts feel sleepier and sleepier, and eventually they go to sleep and never wake up.
However, all of the Apollo spacecraft have systems that can remove carbon dioxide from the air in a process known as scrubbing.
You blow the air through crystals of something called lithium hydroxide, and there's a chemical reaction, and it captures into a solid form the carbon dioxide, takes it out of the air, and then you get fresh air coming out the other side. The command module had a scrubbing system, so did the lunar module. But the lunar module was designed to carry 2 men for 2 days, whereas now it had to carry 3 men for 4 days. So that's 3 times longer, 3 times more carbon dioxide being exhaled by these men.
With this additional carbon dioxide, the scrubbing canisters in the lunar module are being overwhelmed. However, the command module has plenty of unused canisters. But with the command module powered down, its scrubbing systems are not operational.
It wasn't possible to take the lithium hydroxide crystals from the command module and place them in the lunar module because the shapes were different.
Because 2 manufacturers had bid and competed for these 2 separate spacecraft, and they each built their own design of lithium hydroxide canister.
The command module canisters of lithium hydroxide were square cross-section, and believe it or not, the ones in the LEM were round cross-section. So you couldn't take a canister from the command module and just plug it into the slot in the LEM.
So the problem that the mission controllers faced and the astronauts faced was how to make a square peg fit a round hole.
This was a very serious problem. I mean, it could easily have been the end of the rescue mission had they not solved it.
NASA engineers must rapidly devise a system that converts the square command module canisters for use in the lunar module before the carbon dioxide reaches dangerous levels.
Okay, just some info. We're working up a procedure for you to use command module LiOH canisters in the LEM so that you can continue scrubbing the LEM atmosphere. So sometime in the future we'll be coming up to you with that procedure.
A group of life support engineers at NASA knew immediately after the oxygen tank rupture that if the lunar module was used as a lifeboat, then carbon dioxide poisoning was going to be a problem. They also knew the astronauts would somehow need to patch command module canisters into the lunar module's life support system if the crew were to make it home alive. The responsibility fell on this team of engineers to construct a canister adapter using only equipment available to the astronauts on board the spacecraft before CO2 levels get dangerously high.
The guys said, okay, lay out on the table what we've got, and let's get a lunar module canister and a command module canister. How do we bring these together?
Here again, I think we must pay credit to NASA for its incredibly philosophically intelligent way of organizing missions. Everything that went on the spacecraft went onto an inventory. So the people on the ground knew everything that was on the spacecraft, and that gave them the opportunity to sort of assemble all of this in their minds and say, hey, what have we got up there? What can we actually put together to overcome this problem?
Within hours, the team have created an adapter using spacesuit hoses, plastic bags, and cardboard flight plans. But holding all of these components together to create the vital airtight seal is one of NASA's secret weapons.
Duct tape. We couldn't have gone to the moon without duct tape, and we certainly wouldn't have got the Apollo 13 crew back without duct tape. It was very, very useful.
If you're in a weightless environment and you want to stop your pencil kind of just wandering off into somewhere else, you stick it to the wall with a piece of duct tape. You're forever sticking up lists of instructions or lists of things to do or pieces of equipment to the walls with duct tape. And clever minds might think of a way of getting around it if you didn't have duct tape, but it was the obvious thing to use, and luckily they had some there. But I use the word luckily, I mean, it was because it was a useful thing to have, and they had it on board.
This is the scavenging hose, the exhaust hose, if you will, from the suit. And we just put the lithium hydroxide canister on the end of it, and it's not so easy to fasten on there.
They placed the rectangular lithium hydroxide canister inside the plastic bag with a hole in front of the astronaut's spacesuit pipe that then allowed air to be pushed through that lithium hydroxide canister.
We've used a data card out of the flight plan to make a structure so that the plastic cover here won't collapse on the end of the hose.
And they then found a way of connecting at the other end of the spacesuit hose to a spent lithium hydroxide canister already fitted in the lunar module.
And we've had one of these running for about 3 hours over in the 11-foot chamber in Crew Systems, and all indications are that it's doing the job.
So it literally was cobbled together on a desktop. It sounds Heath Robinson, but in fact it was just make, do and mend. And that's often the best way for solutions.
Mission Control's final hurdle is creating a clear procedure for the tired and cold astronauts to follow to correctly assemble the canister adapter.
We wish we could send you a kit, and it'd be kind of like putting a model airplane together or something. As it turns out, this contraption will look like a mailbox when you get it all put together.
The ground read us up a procedure in order to adapt some of the command module lithium hydroxide canisters for use in the LEM. And as they read this thing up, Jim and I constructed one of these things.
Cut a piece of tape this long, put it up there, do this, do that. So the guys in the LEM actually replicated this, and it worked a treat. You know, within an hour of switching it on, the carbon dioxide levels were way down, and they were through that really serious consumable problem.
So these were very effective devices, and we used 4 of these command module canisters and never did use the main canister that we had in reserve for the LEM.
We're now showing 0.1 partial pressure of carbon dioxide in the lunar module. So apparently the engineering using the command module lithium hydroxide canisters and the plastic bag and the suit hoses is working out all right. And at 96 hours, 3 minutes ground elapse time, this is Apollo Control, standing by.
Having avoided carbon dioxide poisoning, the crew can breathe easy. But concerns are now growing at Mission Control about the spacecraft's trajectory. The flight dynamics team tracking Apollo 13 can see it drifting off course. Although this drift is small, its impact on the capsule's re-entry into the Earth's atmosphere could be disastrous.
You are looking to enter the Earth's atmosphere around the side of this great big sphere at an angle of between just 5.5 and 7.5 degrees, coming all the way back from the moon. So the precision with which you align the flight path is crucial to keeping the crew alive.
If Apollo 13 stays on this drifting flight path, its re-entry angle will be too shallow, and the capsule will skim off the Earth's atmosphere, stranding the crew in space. The astronauts must once again perform a precision burn of the lunar module's descent propulsion system and trim their flight path, steepening the capsule's re-entry angle, ensuring it is captured by the Earth's atmosphere. But if the burn is not accurate and the angle is made too steep, the heat shield on the capsule will fail and the crew will burn up during re-entry. The astronauts' lives now depend on the accuracy of this maneuver, but with no power to run the lunar module's primary guidance computer, it was shut down after the last acceleration burn. Mission Control now need a method to precisely align the spacecraft to have any chance of correcting the re-entry angle.
The procedure for putting the spacecraft in the proper attitude would be to use the Sun and the Earth as reference points. This, of course, would be a backup procedure. The normal procedure would be to use the onboard guidance equipment, and only in the event of some unforeseen failure would this backup procedure be used.
With no power available for the lunar module's primary guidance system, the crew must use the secondary abort guidance system, which consumes less power. This system will help the crew position the spacecraft for an accurate burn, but must first be calibrated to be of any use. The technique that must now be used has only ever been trialled once before, by only one astronaut, Jim Lovell.
On Apollo 8, we were concerned with perhaps losing a platform on the return voyage home, and since no one had ever made a lunar trip before, we were looking at sort of way out ways of determining how we could make these corrections home. And some of our people here at MSC had come up with an idea about using the terminator of the Earth to orient the spacecraft and then the sun position to get orientation and pitch. And with that knowledge, we could then make corrections to correct our angle of entry into the atmosphere.
This backup procedure uses the Earth's terminator as a target. The terminator line is the separation between the illuminated day side and dark night side of the planet. The terminator provides a fixed target on the Earth and can be used to establish an accurate alignment.
And the way that they did this was to use the Crewman Optical Alignment System, or COAS. And by maneuvering the spacecraft so that the COAS had the Earth's terminator aligned with the site, it was possible to create the correct geometry for the burn to take place in the right direction.
So at 105 hours, they gave us instructions to relight the descent engine, to orient the spacecraft in this manner, and give this particular procedure a try. And when they read up the procedure to us, I just couldn't believe it, because even on Apollo 8, I thought I'd never in all the world have to use something way out as this. And here I was on Apollo 13 using this very same procedure that was developed some time ago.
Okay, Jim, now basically if you put the horizontal line on the COAS on the horns of the Earth, that will put us in burn attitude.
Okay, I think I have a handle on the attitude, the way the Earth should look at the COAS.
Thank you.
And thank you.
This was a really complex problem because without the benefit of automated systems, it was a three-man job.
Because it was a manual burn, we had a three-man operation. Jack would take care of the time. He'd tell us when to light off the engine, when to stop it. Fred handled pitch maneuver, I handled the roll maneuver, and I pushed the buttons to start and stop the engine. So maybe we ought to recommend a three-man LEM after this, I don't know.
That kind of maneuver takes an immense amount of skill, and this is where the selection of test pilots for the astronaut teams became really important. Here were people who were used to jobs in which their lives depended on making very precise, good, snap decisions, controlling aircraft in often very precarious situations. And so the Apollo 13 pilots were absolutely the right people to undertake this maneuver.
Okay, stand by. 2, 1, mark it.
Ignition.
Coordinating that maneuver between the three pilots was something that had to be done right first time.
Thrust looks good. Shut down.
And it's that test pilot background that really gave them that ability.
Okay, looks good. Nice work.
Let's hope it was.
Despite being cold and tired, the three astronauts execute yet another perfect burn maneuver, correcting the flight path and the critical re-entry angle.
How's it going, Fred?
It's fine.
Just wanted to let you know that you're pretty much right in the middle of the fairway there. And well, everybody down here is 100% optimistic. Looks like we're on the upside of the whole thing now.
Okay, that sounds good.
Jim, we're ready to put that battery back on the line.
Now you want us to put battery 2 back on. Is that a firm?
That's a firm.
Okay, it's coming out. Bat 2 is on the line.
Within hours of the oxygen tank rupture, Apollo 13's main power supply was dead. Without oxygen, the service module's 3 fuel cells could not generate electricity. But before the crew could evacuate to the lunar module, the command module systems started draining power from its precious re-entry batteries. This limited supply is the only power available for the capsule during re-entry.
The importance of the command module batteries is that you separate off the service module from the command module before you get to re-entry. And at that point, you lose all your power from the fuel cells. So you have to have batteries in the command module to keep you going, and the re-entry batteries do that job. And without them, you can't operate the command module through re-entry.
There was no way that the astronauts would survive if the re-entry batteries on the command module had less than full charge.
It has now been 3 days since the oxygen tank failure, and with Mission Control gearing up for the spacecraft's re-entry, their first concern is somehow recharging the command module's depleted batteries.
With no fuel cells on board to charge those batteries up, there was only one other solution, and that was to use the batteries in the lunar module to top up the batteries in the command module.
Basically a trickle charge, where you just keep it bleeding away while you're also using the main power of the lunar module to keep the main environment alive until you cut loose and you're just in the command module.
During preparations for Apollo 10, the Mission Control team had faced a training simulation, which also required the lunar module to recharge the re-entry batteries. Now, thanks to NASA's rigorous training program, ground engineers already have a proven procedure for battery charging at the ready. And having shortened the flight time earlier in the mission, there is definitely sufficient power in the command module to keep the crew alive and supply enough charge to the command module batteries.
We have a procedure which involves power transfer from the LEM to the CSM.
Okay, Houston, Aquarius, so we go for proceeding with battery charge.
Okay, go on the battery charge.
Roger.
The crew at this point has successfully completed the transfer of power from the LEM onto the command module battery charger, which is charging the 3 entry batteries to bring this from its current level of 20 amp hours up to about 40 amp hours, which would be essentially a full charge.
Our flight progressed that way down to about 5 hours prior to entry of the atmosphere. And we were just merely hanging on. We had a dead service module. We had a command module that had no power to it. We had a lunar module that was a wonderful vehicle to travel home with, but didn't have a heat shield, unfortunately, and shortly we'd have to abandon her.
In preparation for re-entry, the service module is jettisoned, giving the crew their first chance to see the extensive damage to their crippled spacecraft.
You can jettison the service module when you're ready, no big rush. Okay, sounds good.
Jim and Fred were in the LEM, and when Jim yelled fire, I jettisoned the service module. And it went off, and Jim began to pitch around to try and photograph it.
It was, to me, sort of an amazing sight.
And there's one whole side of that street missing.
Is that right?
Right by the high gate antenna, the whole panel is blown out. Almost from the base to the engine.
Copy that.
I couldn't see exactly what was damaged. I could see material hanging out from the interior, and Fred was taking pictures and Jack was taking pictures of the service module, trying to capture some of the damage that we could see.
With the dead service module set adrift in space, Mission Control and the crew turned their attention to powering up the frozen command module capsule.
Brown, of course, was working feverishly with Jack in the command module to make a successful entry through the atmosphere.
Aquarius, Houston.
Go ahead.
Okay, you're go to start powering up the command module.
Righto, we're starting now.
Mission Control have developed an entirely new procedure for powering up the command module from scratch, something NASA never believed it would have to do while the capsule was in space.
The procedure in the command module was quite lengthy because we really threw away the book. We had never powered down a command module in space, and we had never reactivated one. And we wanted to get it right, and so I read back every switch and every circuit breaker.
But with an already limited power budget and time frame, this procedure is further complicated by the freezing temperatures on board the spacecraft.
They were breathing out water vapor. This was just condensing on the walls, running down the walls and windows. So there was a real concern about the moisture.
If things had not been insulated well and sealed, it would have got into the electrics and could have caused short circuits. They probably wouldn't have got back.
The crew of Apollo 13 will now owe their lives to the lessons NASA learned from the Apollo 1 fire, when 3 astronauts were tragically killed in a test command module.
The Apollo 1 was an incredible tragedy for NASA, and obviously for the families involved. But it kind of brought NASA up to a halt. You know, it was just at the beginning of this program, and they'd lost 3 astronauts. That was a terrible shock.
The Apollo 1 fire was caused basically by bad quality workmanship in the wiring and NASA's lack of understanding of what it meant to pressurize the command module well above atmospheric pressure with pure oxygen. As soon as you do that, the flammability of materials increases tremendously and things burn so rapidly.
When a wire in one of the capsule's electrical systems arced, flammable material in the pure oxygen environment caught fire immediately, killing the crew in seconds.
So NASA learned a lot of lessons from that, about switches, about wiring, about inflammable equipment.
There was a materials review all through the space program to make sure that anything in an oxygen atmosphere in a cabin was non-flammable. The funny thing is, they didn't look inside the oxygen tanks, and they were 100% oxygen with flammable materials in them, and that, of course, was one of the causes of the problems we had on Apollo 13.
But thanks to the insulation improvements made to the command module after the Apollo 1 disaster, condensed water in the Apollo 13 capsule environment will not short out any vital re-entry systems during the power-up.
I think they did an amazing job to get it powered up, considering it had been practically frozen for quite a long time.
I guess I really wasn't thinking along those lines because I knew that we were re-entering very shortly and that regardless of the damage to the heat shield that you had to take it or not take it.
After the Apollo 13 mission, a review board was set up by NASA to investigate the cause of the oxygen tank failure. And it was eventually determined that an unlikely chain of events had resulted in a fire in oxygen tank number 2, causing it to rupture. But during the Apollo 13 mission, neither the crew or NASA had any firm ideas about what could have caused such a catastrophic system failure. Many at Mission Control had expressed their concerns about the integrity of the command module's re-entry heat shield. If there had been an explosion or meteor impact on board, shrapnel and debris may have cracked this vital protection against the intense heat of re-entry. And without an intact heat shield, the capsule and crew would burn up in the atmosphere. NASA has achieved the impossible. They have worked tirelessly and returned the stranded crew from the edge of disaster all the way back home to Earth. But Mission Control can do no more. Now all that stands between life and death for the crew is the hope that the command module's heat shield is intact.
My only thought then was, as I was sitting by myself inside the lunar module, I could see the Earth because it was the nice big triangular window. Well, Fred and Jack were powering up the command module, and even though it maybe wasn't noticeable to me, it looked like it was getting bigger and bigger and bigger. And I kept yelling back to Jack, "How are you coming? Are you doing fine? You know, when can I leave Aquarius?" Yeah.
He was a little bit nervous when he was kept asking. He kept saying, "Jack, how you coming? The Earth is getting bigger." I think he was trying to hurry me, but I don't know.
But Jack did a fine job, which was, I think, accountable for some of our good guidance into a landing. I then went from the lunar module, closed the hatch, came on down, and we jettisoned the lunar module and came on in with a spacecraft.
With just 1 hour before re-entry, the crew must abandon the lunar module, the vehicle that has acted as a lifeboat for the last 4 days, and save their lives. The trials of the Apollo 13 mission remain a testament to the flexibility and reliability of the Apollo lunar module.
Okay, you are go for fire alarm. Real fire. Left jettison. Okay, copy that. Farewell, Aquarius. Thank you.
This is Apollo Control Houston at 141 hours, 31 minutes into the flight. We've had lunar module jettison. Apollo 13, the age of Aquarius ended at 141 hours, 30 minutes, ground elapsed time.
Well, I'm very much disappointed, just as Fred is, and Jack, that we couldn't complete the mission. Palomaro has so much to offer, we thought. We spent an awful lot of time on it. I, of course, would like to have landed on the moon, but I feel that perhaps what we got out of this flight was also well worth it.
The command module now plunges into Earth's thick atmosphere, losing radio contact with mission control. If they can survive re-entry, the astronauts will finally be home.
Apollo Control Houston, the period of blackout for the spacecraft should have begun about 20 some odd seconds ago. Apollo 13 should be coming up on max G right now. We have about 1 minute to go now from time of end to blackout. Continuing to monitor this Apollo Control Houston. Apollo 13 should be out of blackout at this time. We're standing by for any reports of acquisition.
Odyssey Houston, standing by, over. Odyssey Houston, standing by, over. Odyssey Houston, standing by, over.
Okay, go.
Roger that. Odyssey Houston, we show you on the mains. It really looks great.
Extremely loud applause as Apollo 13 on main chutes comes through loud and clear on the television display here.
Roger. Recovery on Apollo 13, Apollo 13. This is recovery, and your chutes look good.
The floor of the Mission Operations Control Room now crowded, and there are visible smiles on the faces of the flight controllers and astronauts in this room.
Lord, we joyfully welcome back to Earth astronauts Lovell, Hayes, and Swigert, who, by your grace, their skill, and the skill of many men, return to us safe and whole. Amen.
I kind of think one of the most important points that can be made of this flight is the cooperation and the coordination and the initiative that people have when suddenly faced with an unusual situation that can respond to come up with the answers. And they did. They read us up procedures. Fred, Jack, and I practiced these procedures by reading them and then completed them. I think it's amazing the way that people can respond so fast to get this job done.
You know, there's a saying about a steely-eyed missile man, about people who work on rockets and spacecraft. And that accolade is only given to a very cherished few who have that quality, what you might call the right stuff. It was not until all those 3 parachutes came out and you saw splashdown that then all those emotions were released.
Personally, I regard Apollo 13 as an immensely impressive example of engineering. The systems engineering, the organizational engineering was so solid, was so intelligent, was so well structured that when the accident happened, the organization was found totally capable of dealing with it. And I think that's very impressive, and I can't imagine why anybody would want to be anything other than an engineer.
It was certainly an amazing achievement. Obviously, we were really over the moon that we got them back.
I think Apollo 13 did show NASA and engineering their very best, and it's a matter of pride to have worked on the Apollo program.
Being able to take a crew of 3 astronauts in a severely wounded ship, bring it around the moon to a safe landing back on Earth using techniques which in many cases hadn't been thought of until that moment in time is a remarkable achievement. I think Apollo 13 is possibly the pinnacle of NASA's achievements in space so far.
Failure is not an option. And it was that idea that we could prevail, that we had to respect the science, the physics, and the engineering, never let it get away from us, but we can do these things. It was the finest example of that spirit that's not only in NASA, it's within people, this is humans that did this. In this situation, and all similar situations, it's really about people and about what they give beyond what they're asked for.